Hi Rahul, I make you the presenter. राहुल आपकी आवाज नहीं आ रही.
Okay, Nishtha. Thanks a lot. Thank you. Damini, you have to make me presenter again.
Okay, Rahul, 1 minute.
Okay. So guys, meanwhile, the agenda for the day, I'll just let you know. Thanks, Damini. Yeah. So agenda for the day is we will talk about the advanced boosting algorithms. So yesterday we talked about the gradient boosting model. Then now today we are going to talk about the extreme gradient boosting, like what is extreme gradient boosting, how it works. Then the two other variations of boosting models, which is the light GBM and the cat GBM, why we primarily use them. Okay. And after that we will implement these, and then we will move on to the time series. Okay. So to start with, just a recap, when we talk about ensemble models, bagging is a separate category where trees are built in parallel, so it's a bit fast. Okay, but those trees are deep. That's one thing. जब हम boosting की बात करते हैं तो as the name says कि one tree is boosting the another, right? Trees are dependent on each other, so they cannot be built in parallel, rather sequentially. Okay. अब इस सीक्वेंशियल ट्रीज को बनाने की अप्रोचेस अलग अलग हो सकती हैं. ओके ओके सो ट्रीज को बनाने की अप्रोचेस अलग अलग हो सकती हैं. नाउ व्हाट दोस कैन बी इज व्हाट दिस डिफरेंट मॉडल्स आर. सो एडाबूस्ट कहता है कि भाई हम सीक्वेंशियली तो ट्री बनाएंगे, लेकिन हर एक ट्री अपनी खुद की प्रेडिक्शन देगा. ओके हर एक ट्री अपनी खुद की प्रेडिक्शन देगा, और एट द एंड what will happen is we will have some weights which are assigned to the trees. Accordingly we will get to the final result, that what we saw in the adaptive boosting. Okay, that was adaptive boosting, where each tree was running in sequence, but each of them was giving you some prediction, and at the end there was some weight which was associated to each of these trees. Okay, but after the adaptive trees came additive trees. Okay, so what happened was, so we were talking about the adaptive trees, but then came the additive trees. Just to let me open this. ये बहुत ही सिमिलर है, इसलिए इसको मैं रिवाइज कर रहा हूं एक बार on a very basic level. Yeah, so adaptive boosting is trees are being built in sequence, but they are not getting added up. Okay, they are not getting added up. It's still independence in terms of their prediction. Okay, just it's the weight which we were using to finally come up like what should be the prediction. Okay, there was an importance associated with each tree. Some were more important, some were less. That's what the adaptiveness is. But as we move to the next, which is additive trees. Okay, so this is an additive tree thing, where what happens is finally, like ट्री अभी भी sequentially बन रहे हैं, लेकिन अभी वो prediction भी independent नहीं दे रहे हैं. It's like additive model, they are adding their predictions to come to the final result. So all the models that we are going to talk now, the boosting models, they are additive. Okay, so we sum up the predictions from each to come up to some kind of prediction. Okay, so now अगर वो regression है, I told you how it will work. अगर वो classification है, then I also told you that there is log it function that will be there, because क्योंकि confusion यही होता है कि आप additive model की बात कर रहे हो, तो additive model आप add कैसे कर सकते हो classification के केस में, क्योंकि एक yes कहेगा एक no कहेगा, आप कैसे ऐड करोगे. तो प्रॉब्लम वो नहीं है, बात ये है कि उसको हमने सॉल्व कैसे किया कि हर एक ट्री एक लॉगिट वैल्यू देगा, उस लॉगिट वैल्यू को मैं ऐड अप करता चला जाऊंगा और फाइनली उस पे सिग्मॉइड फंक्शन लगा के मैं प्रोबेबिलिटी निकाल लूंगा. तो अल्टीमेटली जो कल हम एक इंपॉर्टेंट चीज की बात कर रहे थे वो ये कि जीबीएम मॉडल में चाहे रिग्रेशन हो या क्लासिफिकेशन, it's a additive model, means some mathematical thing is happening behind the scene, right? So that means it's the residual based approach that we are taking here, the residuals that are being predicted by the model. Okay, so residuals in the case of regression तो समझ आता है, but classification के केस में क्या होगा, तो logit values पे काम करेंगे हम. अगर logistic regression हमें याद है तो मतलब log of odds, right? So because that is also a numerical value. So that's how the model starts. Initially we take up the average, we put it here, okay, and then we further proceed. But now a lot of organizations were working to improve the performance of this model, the GBM model. The problem was it's a sequential model, right? And also I told you that models are not stumps, they can grow. Like on my screen if you see, right, they have length of depth of 2, right, each tree. It can be up to 3, 4, I told you, right? 8 से लेके 32 तक की डेप्थ हम ऑन इन जनरल रख सकते हैं, राइट? तो ट्रीज लाइक जैसे जैसे डेटा मेरा बढ़ रहा था तो जीबीएम की परफॉर्मेंस घट रही थी. ओके, it was used to take more memory or cache and was getting slow. So to solve that problem, a lot of organizations came in and they did some research and they gave us the advanced models. Okay, so normally you guys talk about what, right? Normally you talk about cart, right? When we talk about the decision trees, you talk about carts. Now there are some important terminologies we are going to talk about here. But now with the additive models, came the MART and the DART. Okay, the MART and the DART. So the MART is nothing but the multiple additive regression trees. Everything is a regression tree, right? Because we are building it on residuals. So it's regression trees. And it's a multiple additive regression trees, which the GBM model is. Okay. But to solve the problems of this GBM came XGBoost by an organization which is DMLC. So DML organization, they gave up the XGBoost and they did a lot of enhancements, and DART is like one of the concept here, where it's D for dropouts and A for additive, RT for regression. So it's a dropout additive regression trees. Dropout is one of the concept that is taken from the field of neural networks. In neural networks, there is a thing of dropouts which is being taken up here. So XGBoost में बहुत सारी चीजें की गई, तो dropout is one of the thing. It's not the only thing. Okay. And subsequently, more models came in. Microsoft Microsoft launches the Light GBM, which also uses the DART concept internally. But Light GBM is more faster than XGBoost. Okay, so XGBoost is faster than the GBM. Light GBM is further faster than XGBoost. And parallelly, the open source community also gave one more model, which is, once again, which is the cat boost or the categorical boost. Cat as in categorical, that means the categorical features can be handled by this model, which is the prime purpose of this model. Like if you have categorical features, you don't need to do one hot encoding or one hot encoding or label encoding anything. It automatically handles it. So that's why it's categorical boosting. It internally converts the stuff into the number, the categories into numbers, which was not there with the sklearn models, right? Okay, so how the things evolved is we moved from the cart to the world of MART and then to the world of DART. These things may seem confusing in the starting, but it's not. So from cart, we moved into the adaptive models to make it simple for you. Adaptive models and then additive models. And additive models, MART and then DART. And then further, these also uses the DART, but along with that, a lot of other things. Okay. So let's put it this way. Okay, so additive models is like GBM, XGBoost, Light GBM and CAD Boost, and हर एक जनरेशन के साथ आपके ट्रीज फर्दर फास्ट होते चले जा रहे हैं. GBM से faster है XGBoost, XGBoost से Light GBM and then CAD Boost. Okay. Okay. Now there are certain links I have put in. You guys can go through them. What those links are about. Okay. So now let's talk about the XGBoost, Light GBM and CAD Boost. So on my screen here, like if you can see, right? Yeah. So this is one of the very famous comparison chart between the XGBoost, Light GBM and the CAD Boost on a particular amount of data set by multiple companies. Okay. And how it performed. Okay. How it actually performed. That's what it's talking about. So here if you see, like the reduction in the time, like CAD Boost is faster as say compared to the other ones. Okay, in most of the cases CAD Boost is winning in most of the cases. XGBoost से Light GBM faster है in certain scenarios, not in all the scenarios. That we can check. Okay, so Light GBM has other benefits along with being faster, but it's not like it's always faster than XGBoost. There are certain scenarios, but CAD Boost has really outperformed most of these models. Okay. And also the accuracy, like the error is also decreased. Okay, error is also decreased with these new models. So it's not only accuracy that they focused on, it's they also focused on decreasing the errors while we enhance these models. We'll see how they work. Okay, so let's start with the first one, which is the XGBoost. So XGBoost, what XGBoost did was, how XGBoost is faster, right? So as the name suggests, it's extreme gradient boosting. So boosting भी है, sort of gradient operations भी है. Those are all the times that are taken. I'll share the links to you. You guys can check those comparisons. Okay. Now, extreme is because of some of the important things that this model do, as in what it do mathematically and what it do to handle the memory and the processor. So if you look here, XGBoost model first of all handles the memory in a better way. The memory as in अगर आपका डेटा बढ़ेगा तो आपको ज्यादा से ज्यादा मेमोरी चाहिए, right? So gradient boosting is not able to handle huge amount of data. उसका performance बहुत slow हो जाता है, तो it do the cache utilization in a better way. Plus it uses your CPUs in a better way, as in when it comes to multi-core processing, it do it in a better way as compared to the other models. But how it do that is by using the advanced data structures, as in the sparse matrix. Okay. I hope you guys know what data structures are, right? Data structures are nothing but when we talk about list, array, right? A matrix, all these are data structures, right? Right, perfect. So the better the sparse matrix you use, the better the performance of the model. Okay, but then the question comes, as we saw in the previous one of the models where we were using a sparse matrix, right? Can anyone tell me what was that problem which we were solving? 45 million records and then 45,000 were actually the data. Can anyone recall which was the problem that we were solving, where we saw the sparse metric? NLP, ham spam. Yeah, very good, guys. and which model we were using to classify ham and spam? Very good, Anam. Yeah, so it's naive bias, and yeah, Rahul, it was NLP. Yeah, oh, perfect. Okay, but now the question is, if you guys, as I told you, did dive into the matrix field, you will see these sparse matrix are further of multiple types: COO, CRC, CRS. These are the types of sparse matrix. Okay, so the better tuned sparse matrix you use, the better the performance of your model is. Okay, so sparse matrix is of multiple types. Let me just check. I can show you that. So you guys can go through this, the type of sparse matrix, CSC, CSR, BSR, LIL, DOC, CO. There are a lot of such stuff. But to make it clear, मैं बोलना चाह रहा हूँ यहाँ, मैं आपको एक simple example दिखाता हूँ. So I'll explain you CO. So let me just check if this one is CO or not. 3, 4, 5, 7, 0, 0, 0, 0, 0, 2, column 2. Yeah. So this is the CO representation. Okay. So first of all, you guys, if you look on my screen, right, what a dense matrix is and what a sparse matrix is, right? A sparse matrix mostly have blanks. Okay. Okay, blanks or nulls. Because you cannot say it's 0, because 0 is also a valid value. We can say that 0 represents null if we are saying it, but ideally zeros are not what makes it sparse. Agar is में 0 hoga, तो that's not sparse. But we say that we are representing nulls with zeros, then we can say okay, that's fine. It's a sparse. Okay, so to convert this sparse matrix onto the left hand side into the actual data structure, how memory holds it. Okay, so if we convert it from the left to the right side, lesser memory will be used, guys, and it will be more optimized mathematical computation. So if you look here on the screen and I am saying that zeros are nulls, then only important data is like 3, 4, 5, 7, 2 and 6, right? So in the field of mathematics, like, or even what H2O company also did, they also used better data structures only. What tensors are better data structures only, right? Because एक लिमिट के बाद कंप्यूटेशन में आप कुछ नहीं कर सकते, आपको मैथमेटिकली चीजों को ट्यून करना पड़ता है, तो वहां पर ये सारी चीजें काम आती हैं. Okay, so what happened is, here we store the data in the form of row, column and value. This is a CO representation of sparse matrix, where values are all the dense values, so like 3, 4, 5, 7 in that order. We keep storing it, and row and column is nothing but its coordinate. So CO is like coordinate. So like in coordinate geometry we have. So what's the row number? Row number is 0. Column number is 2, 0, 1, 2. So it's row 0, column 2. So that's where 3 is. Row 0, column is 4, right? 0, 1, 2, 3, 4, 4. So that's where you have 4. So now instead of storing this data, we will store it in this format. It will be faster while doing the mathematical computations, and also to store it in memory, it will be taking lesser space, and that's what. And the other benefit is कि कल को अगर आपको जरूरत हो तो आप इस फॉर्म से वापस इस फॉर्म को रिकवर कर सकते हो. ऐसा नहीं है कि आपने अगर इसको हटा दिया तो this is lost, because you already have the coordinates, right, of the dense elements. So this is one of the sparse matrix representation. Similarly, there are multiple representations which you guys can go through. Ideally, you should know if you go for the advanced interviews. So this is all being handled by NumPy and SciPy. So especially in the field of neural networks, these things are quite important. Okay, neural networks is all matrix algebra and matrix and vectors. Okay, so I pinged it to you. Go through this. This is all SciPy. Okay. So coming back, So that's the first thing, that if you have the training data, which is huge in terms of features and in terms of records, XGBoost first of all handles it properly in memory in the form of these sparse metrics, and then it processes it also in a very faster manner. तो in the field of computer science दो ही चीजें जरूरी होती है, memory and processing. अगर आपने memory processing handle कर लिया, then you can handle huge amount of data. Okay, let me put it there. Okay, so this is the first intuition of what XGBoost do to make it faster. Why it's known as extreme? Because of a lot of such small things that it did, it become very extreme in terms of performance and accuracy. So extreme gradient boosting is good. It's extreme because of all these small things. It handles the system resources better. It handles the data better. Okay, if someone asks you. But at the same time, what XGBoost did was, it also changed the way in you build the tree. So here, you don't build the tree using that Guinea approach or the LSD, least square deviance approach, right? None of those approaches. Like, your criteria is not MSC here. It's something known as similarity score. So here the tree building process itself is completely changed. Okay, so we have to understand what that change is. So before we go into that, these are some of the important features of a extreme gradient boosting tree. So definitely it's gradient boosting with some gradient that is optimizing some loss function. So all those things are there. But this is the most important part, guys. The most important part. It's a regularized GBM. Instead of saying it's extreme GBM, like extreme gradient boosting, we can say it's a regularized GBM model. Okay, because regularization is something that we do here. And since we are doing regularization, which parameter we can tune, guys? Can anyone ping me the name of the parameter that we tune when we do regularization? Okay, alpha, lambda, whatever, but yeah, it's lambda. As such, it's lambda. But yeah, you somewhere see alpha, but don't confuse alpha with the learning rate in that case, because normally alpha we fix it for the learning rate. And here in the GBM and XGBoost, we have another parameter for learning rate also. So we should not get it confused, right? Because we saw yesterday there is a learning rate parameter also. So here you have alpha as a learning rate and lambda as a regularization parameter. C parameter is actually the inverse of lambda. It's 1 by lambda. Okay. So remember these. Alpha जब भी हम बोले तो learning rate, lambda हम बोले तो regularization strength, C हम बोल रहे हैं तो 1 by lambda. Okay. The another thing is these unique regression trees, right? The way the trees are built here is based on similarity score, not the MSC or the Gini. So we will see that. I'm not going into this greedy algorithm thing, so leave it. The quantile sketch, leave it. Yeah, this I told you something related to sparsity, right? The sparsity awareness, like whether my data is sparse, and then how to store it. COO, CRC, CSC, different approaches, right? A parallel learning, which is quite important. Don't get confused here with parallel learning, because parallel here does not mean that tree are being built in parallel. No. Tree are still sequential. Okay, tree are still sequential. But what is parallel here? A single tree when getting built, can we increase its building cycle? Means can we build it fast? So to build a single tree in a fast way, we do parallel learning. So that's something you don't confuse with. Here parallel learning does not say that trees are built in parallel. Rather, one single tree when getting built, internally it is getting built in parallel. What I mean by that is, when I'm building this tree, like I'm splitting it into 2 nodes, right? Very good. But now when I have to go further down, can I split this and this parallelly? Or should I first wait for this to split and then split it? No. I should, on a particular level, if I'm on a particular level, I should split it in parallel. I told you something known as breadth first search, right? BFS and DFS, right? Algos. So it's something like the breadth first search, where all the nodes which are at a particular level, they are processed or splitted in parallel. Okay. You try to use the processor in that way. So for example, now at this level, 4 operations will be happening in parallel. At this 2 operations, at this 4 operations, further maybe 8 operations, 16 operations. So you are doing that parallel processing within a tree. So that will further help you to build it in a faster way. So that's what the parallel learning is. Cache awareness, as I told you, is just because of this sparse thing, the memory handling is good. Plus, it's you leveraging the cache in a better way. And blocks for out of core computation. So just keep it like parallel processing is happening. So you are using multiple processors or multiple cores of a processor in a better way. So if you have a single processor with 4 cores, nowadays we have quad core and octa core laptops, right? So are we able to leverage those in a good way? So this is all the concept behind it. Now what we look at is how this tree building process happens here, how that is different. So let's start with this. Just take 1 minute, think how it happened in GBM. Okay. Otherwise वो चीजें मिक्स होती रहेंगी मेमोरी में. Okay. So here also the approach is same. Okay. You build a single node, you build a tree, you add them. You build another tree, you add them. Okay. And also you have the learning rate for each of the subsequent trees, right? So the approach is same, no problem, absolutely same. This is to get you to the overall final result, right? Good. But now what happens is how these trees are getting built. So let's see that. So here the example that we are trying to take is, again, you guys can look from the stat quest for more details once I am done explaining you the major things. Start quest I personally like to one of the best one. Yeah. So what happens here, guys, is this is say the drug quantity which is increasing, and say this is the drug effectiveness. So if you are increasing the drug quantity, is the drug effectiveness increasing? Okay. So coming back to this. So with the increasing drug quantity or the dosage, is my drug effectiveness increasing? So this is a regression model. So I'm just trying to predict the effectiveness of the drug on the patient on a numerical scale. So here if you see lower drug dosages were having good impact. Okay. Or I would say the average drug dosage. Lower and very high, they were having bad impacts. Okay. डोसेज या तो बहुत ही कम है, बहुत ही ज्यादा है, तो बहुत ही नेगेटिव इम्पैक्ट्स हुए हैं. ये नेगेटिव स्केल पे है, नेगेटिव साइड, and this is on the positive side, the amounts we have. So we just want now to build a decision tree model. Yeah, Gulzar. Negative means that. Or if you want to scale it, you can bring it all positive and say the lower values have a negative impact and higher values have a good impact. कई लोग negative values handle नहीं करना चाहते, तो वो स्केल कर देते हैं कि माइनस इन्फिनिटी से इन्फिनिटी की जगह 0 से इन्फिनिटी की रेंज में आ जाओ, then lower values are bad and higher values are good, like that. Yeah. So negative as in the bad impact, or in terms of regression you can say numerically it's lesser value, means the lesser value means the bad impact, and higher values means drug was more effective. Okay, now as I told you, right, so here we have to build a regression tree and also regularization, which is important. So there will be a lambda parameter that will be used here. Okay, so initially what model will do, like initially it will pick a random value to start with, say 0.5, and that is not the average. Earlier when we were talking yesterday, it was like take the average of all the values and put it at the drug effectiveness. Okay, but here the model will take some random value which is within the range and put it as the first value, which is say 0.5. Okay, 0.5 is one of the, you can say, preferred value because it's somewhere between 0 and 1, and now we will start to add or subtract the residuals from it. So here also we will still go with the approach of residuals. That's the another thing, but how it's built is now different. So here, first of all, we'll subtract this value with each the value and we'll get the residuals, right? If you see all this minus 10.5, 6.5, 7.5, because we have the 4 observations, we have 4 residuals, and then the tree starts to build to predict the residuals. Okay, that's the first thing. So model initially starts with 0.5 as one of the value, optimal value, and then it subtracts these values with all of these values to get to the new residual as we saw yesterday. Okay. Yeah, Gulzar. So ये तो सिर्फ explanation के लिए है, but it's not the case. And now this tree is being built. But now the question is कि ये जो splits हो रहे हैं, how it know कि doses less than 15 is better, right? अब यहाँ पर क्योंकि एक ही कॉलम है तो वही बार बार यूज हो रहा है स्प्लिट के लिए, और मैंने कल आपको बताया था एक कॉलम बार बार यूज हो सकता है स्प्लिट के लिए. ओके, अगर हम यहाँ एक ही कॉलम की बात कर रहे हैं तो इट्स बीइंग यूज्ड अगेन एंड अगेन फॉर द स्प्लिट unless you reach either to the leaf nodes with 1 record each, or you have some pruning criteria which is set up, right? मतलब अब क्योंकि अगर आपने एक ही फीचर दिया है तो ये भी फर्दर स्प्लिट होगा until you reach 6.5 here, 7.5 here for example. ये तो आई होप सबको क्लियर होगा, राइट? क्योंकि अगर मैंने कोई प्रूनिंग क्राइटेरिया नहीं दिया ट्री में तो ट्री तब तक चलता रहेगा जब तक हर एक लीफ नोड पे सिंगल वैल्यू ना आ जाए. दैट मीन्स there must be some pruning that should happen in this tree, otherwise it will keep growing, right? So the lambda or the regularization parameter actually helps here in pruning the tree. Okay, like when to prune it, when to further not grow it. So that's one thing we'll see. But here if you see, you will start with a 0.5 value somewhere, a middle value 0.5, then you'll subtract the values like we get the residuals, and you build the tree on the residuals. The tree will keep growing if there is no pruning criteria. So regularization, lambda as a parameter, helps you in that. And all of you are aware that more value of lambda means lesser overfitting, right? So if your tree is building, that means it is getting more and more overfitted, right? So if lambda is 0, you will get deep trees because no one is there to prune it. It's getting overfitted, right? But if lambda is 1, that means it's the best possible or one of the good possible pruning you are trying to do by cutting the tree. रिग्रेशन में भी यही था, ओवरफिटिंग को हम अवॉइड कर रहे थे, राइट? तो जैसे जैसे आप लैम्डा को 0 से 1 की तरफ ले जा रहे हो, आपकी ओवरफिटिंग कम हो रही है, मतलब ट्री कट होता चला जा रहा है. और ट्री कट होने का मतलब क्या है? ओवरफिटिंग हट रही है. Simple. So that's the concept. Okay, remember this. Gulzar, what do you mean by alpha? The learning rate, right? So the learning rate does not impact the tree building process. It impacts the final output. Okay. So alpha does not impact here these trees, not these trees. That's based on the lambda parameter and the other mathematics that we are going to talk. But this alpha as such, the learning rate is for the overall loss function of the model, not for the individual trees loss function. As I told you yesterday, right? जब हम कल ट्री के आइट्रेशंस देख रहे थे तो सॉरी जीबीएम के आइट्रेशंस देख रहे थे, हमने देखा था कि लॉसेस घट रहे हैं, तो लॉसेस लेकिन वो जीबीएम के घट रहे थे, ना कि ट्री के घट रहे थे. तो ये अल्फा उस मतलब एंसेंबल मॉडल लेवल पे इंपैक्ट करता है. ओके, but at this level what will impact is the criteria which was MSC earlier, but now it's not MSC, it's similarity score. We will talk about that, and that similarity score further will use lambda to prune this tree. तो अभी तक आपको इतना समझ आ गया कि यहाँ पर भाई ऊपर से क्या चीजें हो रही हैं. सब कुछ सेम ही है, बस ट्री बिल्डिंग प्रोसेस बदल गई और उस ट्री को रेगुलराइज करने के लिए एक लैम्डा पैरामीटर ऐड कर दिया गया. तो इफ समवन आस्क यू in interview what is a regularized GBM, do you know regularized GBM? So XGBoost is nothing but regularized GBM. It's a regularized version of the GBM model. That's it. But it's not only this thing, it also uses those memory handling, cache handling, or the processor multi-core handling, sparse metrics. So that's why a lot of things it's using. Okay, it's a greedy algorithm. So greedy algorithm is another field of computer science. Those of you who wants to study it, or those who are from computer science, knows about the greedy algorithm. Can anyone tell me any greedy algorithm they are aware about? Any greedy algorithm they heard about? In real world, there are a lot of greedy algorithms. It's a field of computer science. Anyone, guys, those especially who has BTechs or maybe MCAs. So I need to tell you these things. Greedy algorithms is a field of computer science, guys. No one knows. Okay. No one heard of Kruskal's algorithm or Prince algorithm? Like these are the two famous ones. Or I don't know if there are BTechs here or not, computer science BTechs. So examples of greedy algorithms are Kruskal's algorithm and the Prince algorithm, which are we study in the field of ADA, advanced algorithm design in computer science. Okay, for finding the minimum spanning trees. Okay, so it's all related to tree building processes in the field of computer science. Kruskal algorithm, Prince algorithm. There are some optimal trees, Huffman trees. Okay, in the field of network, when we have to even find the say shortest route to a particular place, it may be something related to a traveling salesman's problem also. So greedy algorithm is you are very greedy in finding out the best possible approach to solve a problem. So read about this, guys. It's very interesting. Like greedy algorithm for Egyptian fraction to solve this problem of Egyptian fractions. How the greedy algorithm works. Okay, so just note it down, and you have to choose the locally optimal also leads the global solution are the best fit for greedy. So greedy approach, normally what they say is they don't hit the global minima, they try to hit the local minima in very layman terms, and they consider that while they are going in the search of local minima, they will land at the global minima. So they don't target to achieve the best, they try to achieve the good, considering that good will reach to the best. That's what it is. Bit of philosophy, but yeah, read about it. So XGBoost internally takes the greedy algorithm based approach. Okay. So now let me come back to this. Yeah. So this is the formula for similarity scores, guys. Like we have the formula for Gini, we have the formula for MSc entropy. So the similarity score, like how should I decide which column should I split on, right? So if there are multiple columns, which column should I split on? Or if there is only one column which is numerical, what should be the value to decide less than, like the range, right? The threshold rather. So the similarity score is nothing but sum of the residuals and square it divided by the number of residuals plus the lambda. So this lambda, which I was saying, right, is important here. Okay. So consider that initially what happened was you have this initial data, right, where this was the residuals. So you add all the residuals, square them, divide by 4 plus lambda. So let's say lambda is 0 initially. Okay. You are not doing any regularization. Okay. So at that time, we are just considering lambda 0 for our example. Okay. While implementing this model, we can change the value of lambda to see how the model accuracies are changing. But this is the formula. So if you look at, if I put this in the formula, my value was coming as 4. Okay. Similarity should be higher. Okay. When you talk about similarity, it is like homogeneity, right? It's something like homogeneous, how homogeneous your data is. So the similarity here is very less. Here it is more, here it is even more. So that's what the purpose of tree building process is, that with each split, you get more homogeneous data. So your similarity should increase, right? So that's what's happening here. Like similarity was 4, but after that, here it's this much, here it's this much. So as compared to this, your similarity has increased. Okay. Further, here the similarity will be calculated again by putting this in that formula and putting this in that formula. We will get the similarity score. And definitely, if there is only one record, primarily the similarity will be higher as compared to where there are more records. But it's all depend on the formula. Okay, see, it all depends. First of all, Nishtha, bagging does not leave features, right? It reaches the data, the out of bag things you're saying. Leaving the features is a property of trees. Okay. A tree, मतलब अगर आपने 100 फीचर्स पास किए तो एक ट्री हो सकता है कि किसी 10 फीचर पे बन रहा है, अगला किसी 10 फीचर पे बन रहा है, राइट? तो द क्वेश्चन निष्ठा वाज आस्किंग इज कि are there any features which are not used in the tree building process? So that's what I'm saying, right? It's all depends. We talked about max features, right? अगर 100 फीचर है, मैंने कहा मैक्स फीचर 10, तो हर ट्री बिल्डिंग में 10 फीचर यूज होंगे. Okay, which will be picked randomly. And more trees, then more chances of all the features taking part in it. But still it may so happen that some features are not used because you have pruned the tree. So if you prune the tree, some features might be dropped. So whether features are used or not, it all depends on how much pruning you are doing. Okay. So now what happens, guys, once you calculate the similarity score, then the next, okay. So alpha is learning rate and lambda is the regularization parameter. Okay. So now look at this. We calculated the similarity at each level, the parent level, the child level. Yeah. So at each level, we calculated the similarity. But now, जैसे हम पहले हर लेवल पे गिनी कैलकुलेट करते थे और फिर गिनी गेन निकालते थे, या हर लेवल पे एंट्रोपी कैलकुलेट करते थे और फिर इंफॉर्मेशन गेन निकालते थे, तो यहाँ पर भी वही है. पहले हम ये हमारी अप्रोच ये होती थी कि भैया एंट्रोपी जो है वो घटनी चाहिए. तो एंट्रोपी E0 एंड से एंट्रोपी एट दिस लेवल entire level is E1. So the gain used to be E0 minus E1, right? The parent minus child, and this should increase, right? But here the formula changes a bit. We have similarity score S0, for example, here, and on this entire level, including both these nodes, it's S1. But we say it should increase, right? Similarity should increase. So the formula here is S1 minus S0 for the gain. S1 minus S0 is the formula for the gain, because gain should always increase, right? You should always gain in life, right? So you say, if I'm gaining more, something good is happening, right? So that's just the difference in the formula, that if S1 is there and it's higher, right? It's higher. We subtract it to a lower value, right? So we'll get a bigger value. For example, if, okay, let me explain it. So initially, if similarity was 3, I want it to be 4, right? I don't want it to be 2. I don't want it to be 2. Why? So if I put it in this formula, it's 4 minus 3, which is equal to 1. Okay? 4 minus 3. But if I say 2 minus 3, it is minus 1. So definitely I can say that this is giving me more gain as compared to this, right? Because it's a negative value. So I will select this split instead of this split. So what I mean to say, if dosage less than 15 gives me 4 at this level, the similarity score at the combined at this level, and dosage less than say 10, which is another threshold I will try, and after that split, जो नए दो नोड बनेंगे, they will give me 2 as a similarity. Definitely I don't want this one, because this is the problem. This is the one I should use, right? So just a small change in the formula, बस आगे पीछे कर दिया, because gain we want always to be something positive if it is good. So it's S1 minus S0. Here it's E0 minus E1, not E1 minus E0. Okay. So now what happens is, guys, is which node to split on, which column to split on, which threshold to split on is all based on the similarity score and the similarity gain. Like we have entropy and information gain, here we have similarity score and the similarity gain. So we found that these are the good combinations. We will just stick to it, and that's it. That's how my trees are actually getting built. Just don't worry about this thing right now. So first of all, you understood what the similarity score formula is, what the gain is, and higher the gain, the better it is. Okay, now comes the next step. The next step is this thing, which is when to actually prune a node or not. For example, when you are building the tree, you build this level, you built this level, further ये भी एक built होगा level, ये भी further built होगा क्योंकि split होगा. अब ये overfit हो गया model. अब इसको overfit को कैसे avoid करें? So now internally we use this formula, which is gain minus of gamma. So this is the third parameter here, guys. So we have alpha, we have lambda. Alpha is the learning rate, lambda is the regularization hyperparameter, and the third parameter is the gamma parameter, which is something, अगर आप लोगों को याद हो, we were talking about decision tree, something like CCP, cost complexity parameter. So we didn't talk much about it, but there was this parameter CCP. So it's somewhat similar to that. The yeah, Karan, yeah. So it's the complexity parameter for the tree, and this is another hyperparameter that we can set. Yeah, somewhat, yeah. cost complexity, cost of partitioning. Yeah. So you put in this value as in based on your experience after running 2-3 cycles of the model. And now the point is, if the output of this is coming as positive, we will keep that split. But if it comes as negative, we will prune that split. So we will not split at that level. Okay. That's how the pruning happens here. And also I told you that parallelly these nodes will be built. The parallel thing in the XGBoost is one level when getting built is built in parallel to speed it up. That's why it's faster. So if you see here, my lambda, sorry, the gamma that I selected is 150 for this model. We can change it with different values, but this directly prune the tree. So if I talk about yeah, so if I talk about this level, I'll start it from the leaf and go up. Pruning मतलब आप pruning ऊपर से शुरू नहीं करते, कभी नीचे से शुरू करते हो. ओके, तो आप नीचे से prune करोगे, काटते काटते ऊपर तक जाओगे. That's how we prune it. Okay. So till now we are clear on the similarity thing, we are clear on the gain, we are clear on the parallel thing, like the tree is being built in parallel at the level, at each level, at each node level. We know that there is a similarly a cost complexity parameter kind of thing. So if gain is subtracted to that, we can say that we have to prune it. Okay. But there is another parameter which handles the pruning. So if someone asks you in an interview, you have to tell about both the impact of lambda and gamma. So now how lambda impacts the pruning, right? So for that, we have to go back to the formula for the similarity score. So what happens is the regularization parameter or lambda. So when you were putting initially, it was like 1, right? It was 0. So 0 gave you 10.5 minus 10.5, right? But let's say if this value increased. So if this value increased, what's decreasing is the residual, right? So how that impacts is, once again. I'm just looking at this diagram to see if it is important for any consideration to you. Okay, no, that's not needed. So guys, I want you to just try to correlate it. What regularization parameter will do is it will decrease your residuals, right? If it decreases your residuals, what do you think will happen before I tell you? If you're decreasing the residuals, according to you, what should happen? If you're increasing the regularization strength, it's directly decreasing your. So if you increase the lambda, Vipul, it's avoiding the overfitting actually. I'll tell you how. But I want other people to think also. Just think that these values of residuals are going down. तो पहले अगर आपको 2 ट्री मिलके ही आउटपुट दे देते थे, अब ऐसा नहीं होगा. मतलब मान लो आपका आउटपुट था 7.5 प्लस ये 6.5, 7 आ गया था, आपका काम हो गया था, आपको तीसरे ट्री की जरूरत ही नहीं थी. लेकिन अब ये 6.5 की जगह ये 2.5 हो जाएगा. मतलब इस ट्री का कंट्रीब्यूशन और कम हो गया, आपको और ट्रीज की जरूरत पड़ेगी, समझ रहे हो? और एक ट्री का कंट्रीब्यूशन कम करना एक तरह से ओवरफिटिंग अवॉइड करना है, क्योंकि अगर एक ट्री मल्टीपल ट्रीज में से अगर एक एक ट्री भी अपने आप में बहुत ज्यादा इंपॉर्टेंट हो जाते हैं तो वो 2-3 ट्री चीजों को डोमिनेट करेंगे कि भैया जो बोल दिया हो गया। बट अगर मैं मल्टीपल ट्रीज बनाता हूँ, बहुत ज्यादा ट्रीज, और हर ट्री थोड़ा थोड़ा कंट्रीब्यूशन देता है, मिनिमल कंट्रीब्यूशन, देन आई कैन से कि इट्स लाइक अ गुड डेमोक्रेसी वेयर ईच वन इज हैविंग इक्वल और गुड अमाउंट ऑफ से। तो जैसे ही ये वैल्यू 6.5 से कम हो गई तो अल्टीमेटली पहले मेरा मान लो 0.5 और 6.5 मिलके 7 आ जाता था, और मेरी एक्चुअल वैल्यू मान लो थी 7 फॉर एग्जाम्पल। तो आई कुड हैव सेट, मैं ये वाला एग्जाम्पल ले रहा हूँ, नेगेटिव गुलजार हो सकता है बिकॉज दीज आर रेसिडुअल्स। फॉर एग्जाम्पल इफ योर एक्चुअल वैल्यूज, ये आपकी एक्चुअल वैल्यू है ना, मान लो आपकी एक्चुअल वैल्यूज, क्या बताऊं मैं यहाँ पे आपको, it just this values are getting subtracted with this values, so if -10 is minus with -0.5 actually gives you minus 10.5 Gulzar. Okay, so that's why minus 10.5, because I have to get the errors, right? So actual value minus the initial value gives me the errors, right? Gulzar, is it clear why this negative value? Actual value was -10, right? You subtract it, you get this. Similarly, -5 subtracted with this is -4.5, I think, which is this. Where is it? 1 second, let me check. -7.5. Yeah, मतलब ये जो वैल्यू है ये -6 या -7 कुछ होगी, और ये -7.5. So that's what it is. But what I am saying now is, say your actual value was 7, and this added with this gives you 7, and you will find that there is no more scope to build additional trees because now error is not there, right? So you will not build additional trees. मैंने मॉडल को बोला था भाई तेरे को 100 ट्री बनाने थे, लेकिन मॉडल जैसे मैंने कल आपको दिखाया था, राइट, कि उसको लॉस डिक्रीज होता हुआ नहीं दिख रहा एक लिमिट के बाद, वो कुछ रेंज तक तो ट्राई करेगा, बट देन इट विल नॉट फाइंड इट यूजफुल, तो आपके बाकी ट्रीज बनेंगे ही नहीं। अब बाकी ट्री जब बनेंगे ही नहीं तो फिर यही ट्री एक तरह से डोमिनेट कर रहा है आपके प्रेडिक्शंस को, राइट? तो एक तरह से ओवरफिटिंग अवॉइड नहीं हुई। ओवरफिटिंग तो तब अवॉइड होती जब मल्टीपल ट्रीज होते। तो जैसे ही मैंने इन सब के कॉन्ट्रीब्यूशंस और कम कर दिए बिकॉज ऑफ द लैम्डा पैरामीटर, तो अगर ये 6.5 था तो 6.5 divided by 1 plus 1, which is 2, it became 3.5, right? It became 3.5. Now 3.5 from this and 0.5 from this is the 4, and actually 7, so still there is an error of 3. So the model will build another tree, then it will build another tree up till it reaches the value somewhere around 7, maybe 6.9 or 7.1, whatever. But guys, you got it? Is it clear? What's the contribution of the regularization parameter in avoiding the overfitting and also in building the additional trees? That's what it do, and pruning is being taken care by that cost complexity parameter or along with the gain. Okay, read about these things, but these are important things. So here he is just explaining you again what I have explained you so far is you have the initial value, you build the first tree, you multiply the value with 0.3, you get to the actual value. Okay, and since this tree is pruned, right, because of that cost complexity parameter and the lambda, it's pruned as well as its values are adjusted, scaled. तो यहाँ पर 2 वैल्यूज हैं, तो डेफिनेटली जब भी कोई यहाँ पे फॉल करेगा तो we will not predict 6.5 or 7.5, we will predict the average of the two, which is 7. So 7 multiplied by 0.3, which is 0.21 or 2.1, whatever. So you will add it here, 2.1 plus 0.6, so it's 2.6. So you are getting the value as 2.6, for example. So the value that you got is 2.6. So earlier the random guess that you took was 0.5, but as soon as you added one more tree, your values are moving more closer to the actual values. If you see, your value is jumped up. Initial guess was 0.5, but now the values are jumped up to 2.6. So error is reduced graphically if you want to see. Earlier, if the error was this much, now the error is lesser. So your model is taking small steps in the right direction. That we say, small steps in the right direction. So slowly it keeps moving till it reaches either near to this or somewhere up or below. It just stops in this range, this line. Similarly, this line is also going from here to here, see? So it will also reach somewhere here and it will stop. So that means my model is actually getting trained in a good manner so as to avoid the prediction errors. And as I told you, the pruning is being done by the gain minus gamma. If positive, do not prune. If negative, prune. And pruning starts from the child. First you prune the child, then you check for the parent, and then you keep moving up. Okay, so with that, we are done with the XGBoost. So let's comprehend it first, guys. 1 second, let me put on the battery. So just comprehend how XGBoost and this are different. Okay. So XGBoost and this are different. Sorry, the GBM and XGBoost are different in too many ways. In the way they are handling the lambda parameter, the pruning, the tree building process, right? Uh, and also the memory handling. It do the way it builds the tree in parallel way, faster way, right? So it's that's why it's faster as compared to a GBM on the same data set. So now what we have to do, guys, is those of you who have already done it, it's good. Otherwise, do pip install of XGBoost. Just do the pip install of XGBoost. If done, please ping me. It's done. Just do pip install XGBoost and ping me if it's done. Parallelly, also install Light GBM, and then also install the cat GBM or the cat boost rather. Also install the cat boost. Okay. So XGBoost is the important one. Light GBM and cat boost, I'll just talk about very basic things about them, not much detail, but we'll see how they are different. So just install the Light GBM. Sorry, the spelling is wrong. Light GBM and then the cat boost. Okay. Okay, good, very good. So those who have done, great. So similarly, you can install the cat boost and the Light GBM. Do all those and then start the notebook. Gulzar, I have shared the link. You can go through it. I'll share with you again. Just understand the whole concept of the diagram is to tell you that two things: error is decreasing and also the computation time is decreasing. The models are fast. Okay. So if you have installed all these, we will talk about XGBoost first. So read about the things, greedy algorithm and all those things. Okay. Meanwhile, I'm pinging you some links. Just go through them. So these are the dedicated websites by the companies who built this. So one is for the XGBoost, because definitely there are a lot to study if you want around it. So what the XGBoost is all about, the DMLC company which gave it and all, you can go through it. Similarly, this thing, the light GBM. So we will talk about it first. Just confirm me if you guys are able to open these links for XGBoost, Light GBM and the Cat Boost. These are the best places. और आने वाले समय में मतलब और अभी currently भी सारे यही models use होते हैं competitions में. So you can also limit yourself to these 3 models if it comes to a competition. But logistic regression and support vector machine are also very good. But instead of using a single decision tree or even bagging, you should use boosting, and that's to you should use either XGBoost or Light Boost or the Cat Boost, either of these 3. And those of you who are interested can go through the links more. Okay, so this is for the XGBoost, and if you have installed all the packages, let me. My notebook is starting up. It's taking some time, so let me cover up the other 2 topics, which is the Light GBM and the Cat Boost. So as we saw that the benefit for the XGBoost is that it's still doing the gradient boosting, but in a different way, by building the trees in a different way, using some different hyperparameters and but the thing is XGBoost was not available with the sklearn. Okay, ये सारे packages नए आए हैं, so that's why you have to download them separately. अभी sklearn में इनके supports आने शुरू हो गए हैं, हो सकता है कि अगले releases में sklearn के साथ भी ये सब bundle up हो जाएं, आपको अलग से install ना करना पड़े, but for the time being it's to be done. And if you see this is the company DMLC, this is written DMLC XGBoost, right? So which gave this stuff. Go through it. You have the GitHub codes also. If you are interested in the Python, how you have to do it in Python, right? And I told you, right? Julia is another programming language which is equally coming good in the field of this. But when you when you have to implement it, this is as simple as doing this thing. That's it. What it is import the XGBoost once it's installed. Okay. But here you have to pass on your train data and test data like this. You have to pass on the files inside this D matrix, right? So the benefit of this is what I was telling you, right? That is sparse metric. So the model will hold on the data in the form of a sparse metric. So that's what is being specified by this thing, XGBoost.D matrix. Okay. So it's create these sparse metrics. And then like in grid search CV, you create a JSON object to pass on the hyperparameters. So this is how we pass on the hyperparameters here. तो ये थोड़ा अलग है because ये sklearn वाला तरीका नहीं है, but आप लोगों ने सारे तरीके किए हुए हैं, कोई ऐसी कभी रॉकेट साइंस नहीं है. ये पैरम वाला मॉड्यूल जैसे आप ग्रेडियंट बूस्ट ग्रिड सर्च में बनाते थे, राइट? So these are my parameters, the max depth, the eta, the objective function, as in what you need to minimize to build the trees. Okay. And those alpha, lambda, gamma, these are the parameters. Number of rounds, as in how many cycles of training you need to do. So that's it. So what we are going to do is simply xgboost.train, and we'll train the model by passing on the parameters to it in the form of key value pairs. Like this is a Python dictionary, right? It's a Python dictionary. The training data and the number of iterations or the rounds you want to perform, and then you will predict it. Simple. So let's do this. और मैं अगेन अगेन ये बोल रहा हूँ कि देखो ये थोड़ा कंफ्यूजिंग टॉपिक्स होते हैं क्योंकि बहुत सिमिलर हैं काम करने के तरीके इन सब मॉडल्स के. तो द मोर यू स्टडी द बेटर इट इज. And there is more to these models than what I cover. So don't think that जो मैंने cover कर दिया वो सब कुछ है. As I told you, I cannot cover everything. So read more once the class is over. Read more about all these links which I have shared, all the documentation. You will learn 10 different things which are new. So guys, you can also open meanwhile the boosting notebook, the notebook with the name boosting.ipynb. मैंने कल सब अपलोड कर दिया था. आप चाहो तो एक बार गेट पुल कर लो. लेटेस्ट मेरे गिटअप से आपका पुल आ जाएगा. तो रोज आप क्या किया करो, अपना काम स्टार्ट करने से पहले एक बार गेट पुल कर लिया करो और उसके बाद किया करो अगर आपको मेरी नोटबुक्स रेफर करनी है. Data profiling and all that you can see. Okay, so I think notebooks, they are taking time. So this boosting.inb, just open it up. You can copy this stuff from here or you can write on your own. That's not a problem. Okay. So now what we have to do is okay. So I'm just opening it up like what we did yesterday. Yeah. So we talked about. Okay. So we talked about these models, GBM. We saw all this stuff, right? Okay. Perfect. So I'm putting this here, and I'm also pinging you guys. मतलब आप लोगों को मेरा वेट करने की जरूरत नहीं है. मैंने आपको कोड भी पिंग कर दिया है. आप अपना कोई भी डेटा लो और उस पे इसको रन करो. मैं मीनवाइल इसको अपने एंड पे कर रहा हूँ. जस्ट रन इट. So I'm just loading the data first. Then I'll convert it into a data frame if it's not in the form of data frame. Then I'll split it into not train test, rather, yeah, definitely I have to split it into train test. Yeah, I don't know, today it's a bit slow. आप लोग अपने end पे run कर लो, it will not take much time. Just load the data. So what you need, guys, here is so it's only the train data and the test data. So you don't need to segregate your y variable out of it. Okay, just keep it in the train and test, because if you do train test split, वो 4 parts में divide कर देगा. So don't do that. Just pass on your train data, means features plus target. Okay. So just manually you can split it as in using any logic. Don't use that train test split wala logic. So if you look here, I'm just showing you this XGBoost documentation, extreme gradient boosting. So this is the actual implementation of it, where this D matrix is the actual class. There is some quantile based approach, and then the booster. Then XGBoost classifier, regressor, and ranker, all these are there. So normally we use XGBoost classifier and regressor, but there is XGBoost ranker also. If you are interested, read what the ranker does. So we use it for 3 things: ranking, regression, and classification. Okay. Okay. Another thing is you need Python 3.6 and above just to work on this. Not Python 3.5 or will work. Okay. So always go through this documentation. If they are not from sklearn, you need to go through this. Okay. So let me just work on it. So the data that I have is this wine data. We are doing training. So training is done on the training data only, right? So training is on the training data, testing is on the testing data. So here I have my DF column, the DF data frame, which is the features. Now I am looking for the target. I think that's the class. So wine.data, actually wine.data gives me the features. Then I must have something else, which is like wine.target. Yeah. So I have these things, right? So let's say this is my y, and I'm saying this is like y. तो पहले हमें क्या करना पड़ेगा guys? Concatenate करना पड़ेगा data. So guys, you should definitely treat outliers and all before that. You should do scaling also before that, Nishta. Okay. Now the point is, what we have is we have our data separately, like 1 second. So we have our data like features separately, target separately in this wine data. So जब भी आप sklearn के data set से कोई भी data लेते हो वो इस तरह से होता है, ठीक है? So that is one thing. बट यहाँ XGBoost में हमें क्या चाहिए, हमें सिर्फ ट्रेन डेटा चाहिए और टेस्ट डेटा चाहिए, राइट? ट्रेन डेटा एंड टेस्ट डेटा. तो फर्स्ट ऑफ ऑल, train data, test data, that means we need to first concatenate these two to make it one single data frame, right? And then cut it between train data and test data. Okay, so this is first we will do. मतलब जरूरी नहीं है ये, मैं बस आपके नॉलेज के लिए बता रहा हूँ कि कल को अगर आप इस तरह की प्रॉब्लम में फंसते हो तो क्या सोल्यूशन है. कई बार आपको सिर्फ ट्रेन डेटा अलग फाइल में मिलता है, टेस्ट अलग फाइल में मिलता है. कैगल की कॉम्पिटिशन्स में खासकर ट्रेन डेटा अलग होता है, टेस्ट अलग होता है, तो वहाँ ये काम बड़ा आसान है. बट यहाँ थोड़ा टीडियस है, तो आई एम दैट्स वाई डूइंग दैट. अदरवाइज आपको ट्रेन फाइल टेस्ट फाइल अलग मिलती है, हो जाता है. ओके, तो यहाँ हमें पहले क्या करना पड़ेगा, जो हमारा डीएफ है और जो वाई है, इन दोनों को कंकैटिनेट करना पड़ेगा, क्योंकि डीएफ में सिर्फ फीचर्स है. ओके, तो कैन एनीवन टेल मी हाउ टू कंकैटिनेट टू डेटा फ्रेम्स गाइस? कैन एनीवन टेल मी इन पाइथन हाउ कैन वी कंकैटिनेट टू डेटा फ्रेम्स? किया होगा आप लोगों ने, वेरी गुड. या करणदीप, वेरी गुड, एब्सोल्युटली Anam. But your syntax is not correct. It needs to be improved. But yeah, Anam, you are absolutely right. P.concat. When you concat, you pass an array, as in df comma y, and then you pass on the axis on which you need to concatenate. Okay. Cannot concatenate object of the type class, which is a numpy array. Only a series and a data frame objects are valid. So can anyone solve this for me before I tell you the answer? I am pinging you the error, guys. I want you guys to try it parallelly and solve it. Yeah, Aditi, you are correct. I want other people also to answer. Guys, what's the problem here? While concatenating, it's not concatenating these two objects, I would say. Very good, very good. All of you are correct. So this y is what? An array, right? So we need to just say pd dot data frame, and that's it. It's done. And say I'll put it y1, and now I'll concatenate y1. It's done. So small errors, but you should know what you need to do. And now I need to pass it on to the say data. I'll say data set. And now this data set, I'll first see the dimensions, the shape of this data. So it's very few records that we have, 178. So let me take 120 separate and remaining separate. So I'll say what? Train equals to the data set, and then test equals to the data set, right? So all columns but rows from 0 to what? Say 150. Let me take 150. बहुत कम डेटा है ये, बट हम इसको कैगल कॉम्पिटिशन्स वगैरह पे भी रन कर सकते हैं, या बिग मार्ट पे. Then 151 up till the 178. Okay. So now it failed because there are multiple ways of doing the slicing. So slicing didn't happen. So there are multiple ways of doing slicing. First of all, it failed. Slice 0 to 150, none. Slice none is an invalid key. Okay. So can anyone now tell me, there are multiple other things to be done here. So there is dot lock and dot ilock. I can do that also. So there are multiple ways of doing this, but let me first just try why it failed here. Okay, इट रैन एक्चुअली, वो जो मैंने कॉलम्स की बात बोली थी तो वो उसको अग्री नहीं कर रहा था। मैंने कॉलम का भी यहाँ पे इंडिकेटर दे दिया था तो वो अग्री नहीं कर रहा उस चीज से। तो एज आई टोल्ड यू अगेन, यू शुड नो मल्टीपल अप्रोचेस। ये डायरेक्ट स्लाइसिंग अप्रोच है, अदरवाइज मेरे पास .log .ilog भी है, बहुत सारे तरीके हैं। ट्रेन डेटा देख लेते हैं। ट्रेन डेटा आ गया 0 से 149 तक, 150 रिकॉर्ड्स आ गए। 0 से 150, 150 is not inclusive, right? So 0 to 150, where 150 is exclusive. So that means I lost one record here. I should say 150, right? I should not say 151. Remember these small things. Guys, 1 second. So starting 150, I am reaching 177. Okay, total 177. And total records कितने थे? Total records 178 records, मतलब 0 to 177 ही थे. So we didn't miss any record in our splitting. So now my data is available in the form of train and test. So what I need to do is, let me try to pass in here. If it does not allow it, I'll pass it as a file. I'll pass in train here, and I'll pass on test here. So it's done, right? So let's see what dtrain is. So see, it's जैसे पहले हमने स्पार्स मैट्रिक्स प्रिंट हो रहा था, यहाँ पर क्या आ रहा है? इट्स अ डी मैट्रिक्स. Similarly, if I do it here, it's another D matrix, the tree matrix, the D matrix, whatever. It's internal matrix. You pass on these hyperparameters, put them separately with you. ये लिस्ट आपको मिल जाएगी हाइपर पैरामीटर्स की उस वेबसाइट से, नहीं तो डॉक्यूमेंटेशन खोल के भी मैं आपको दिखा सकता हूँ, साइट पैकेजेस में आप देख सकते हैं खुद से. We will simply train this model. Now let's see what's the problem. Okay, XGBoost error. See user workspace XGBoost when release this. Check failed. Predicts.size, info.label, label.size, 150 versus 0. Labels are not correctly provided. Labels are this. Okay. Binary logistic. So it's saying that your target, the labels, they are not correct. So let me just check what the data was. 1 second, guys. But at least tell me if you have reached till this process. Okay. This error I'll solve. This is a small thing. But if you have reached up till this error, just tell me if you all are also getting this error. XGBoost, this is XGBoost, Windows with the local file system directory and data error. No such process. So that's what Nishtha, that's what I was saying, right? You cannot point to this. If anyone is pointing to this, they will get an error. You have to pass on your own data frame here, right? Your own data set, whatever it is. So if you don't do that, you will get this error. So if you just try to run it, you will get this error. No such process, because it's trying to access data.
So we need to manually split it into train.
हाँ, तो हमने ही तो स्प्लिट किया डेटा ना. मैं आपका क्वेश्चन नहीं समझा.
That we cannot use the train test split. So we need to do it manually by iLock and lock.
Yes, you have to do using that. Okay, so guys, please ping me if you are up till this error. Labels are not correctly provided. अगर आप लोगों ने कुछ और डेटा सेट यूज किया है तो ये चल सकता है. but it all depends what the data is. We'll check that. Guys, I just want, yeah, take your time, run this, take this boosting notebook. I'm pinging it, okay? If someone is not having notebook, I'm pinging the codes, just follow along. First, take the data, the wine data, which is, okay, so we are not doing regression here, rather we are doing the classification. Okay, so you just handle the things here and then simple do this. You need to keep splitting the data, like concatenate it, split it, check it. Those of you who want to check for nulls, duplicates, outliers, scaling, standardization, they can do it. Plots and all, they can do it. I'm not going into that. So guys, please tell me once you are done till this place, then we will proceed. So guys, we can take a 15 minutes break. Those of you who wants to take a break, but rest even after I've created train and test data manually. Next, I'll look into it, like what's the problem that you're facing. But for others, please ping me if you're able to reach up till this point, which I told you to. Okay, then you guys can take a 15 minutes break and then we'll connect. Perfect. So those of you who wants to try, keep trying, just keep trying on the errors, and we'll connect after 15 minutes. am I audible? And is my screen visible? You are back. Please ping me. Okay. Okay, perfect. Yeah. So one important thing before we go ahead again, like the gradient boosting models are also known as GBDT. Some places you will see GBDT. Okay. GBDT as in gradient boosting decision trees. So some people says it's GBM, or some people says whether you worked on GBDT. So it's nothing but gradient boosting machine or gradient boosting model or gradient boosting trees. Okay, GBDTs, that's what it is. So it's like parallel tree boosting. So as we talked about, nothing in parallel. It's just when trees getting built, it's getting built in parallel. But multiple trees are not getting built in parallel. Okay. So coming back to the implementation that we were doing. Okay. Yeah. So this implementation, guys, I'm not using this because of some inherent problem which we need to solve later. Because see, the problem that it's giving me is, let me go show you that. Yeah. So देखो पहले तो क्या है कि what we should do, पहले मैं वो बता देता हूँ, then वो error क्या था मैं वो भी समझा दूंगा. So earlier we were directly using the XGBoost model just because of this thing, because we copied it from here. But XGBoost itself has a lot of things. So if you look at here, let me show you this. So if you go into XGBoost, so XGBoost itself does not like give you much of the options like hyperparameters and all. It's just telling you that this is the base package. Okay, this is the base package XGBoost. So instead of using the base package, what happens is if you use this and press say tab, within the base package we have XGBoost ranker, XGBoost regressor, classifier. So the problem with the earlier approach is, ये वैसे भी किया जा सकता है, but उसमें problem ये हो रही थी कि वो क्लासीफायर और रिग्रेसर के बीच में डिफरेंशिएट नहीं कर पा रहा था. तो जो हमारे टारगेट लेबल्स थे वो इट वाज नॉट एबल टू अंडरस्टैंड कि वेदर यू वांट टू डू रिग्रेशन और क्लासिफिकेशन. तो हमें उसमें कुछ और एडिशनल पैरामीटर्स पास ऑन करने पड़ेंगे so that it understands कि ये रिग्रेशन या क्लासिफिकेशन किस चीज की बात हो रही है. So to avoid that kind of problem, we should directly use within XGBoost, there is XGBoost regressor, XGBoost classifier, and ranker. So we should not use this directly because this is sort of a package. We should use the class, the implementation, which specifically is separate for regressor and separate for classifier. ठीक है? So when I am doing this, I am using XGBoost classifier with its hyperparameters. So let me show you that. So the benefit of using this approach is ये वैसे ही काम करेगा जैसे अभी तक आप लोग sklearn पे काम करते आए हो. बिल्कुल sklearn वाली ही अप्रोच है ये. So here you will see this gives you parameters, the hyperparameters of the classifier model that you can set. The verbosity. So earlier हम कहते थे verbose is equal to true. Here verbosity is an integer which is a value between 0 to 3, where 3 tells you what's happening at the back end. 0 will not tell you anything what's happening at the back end. Objective as in what do you want, like whether you want to do that thing, the minimization of a loss function. It can be different for regression, it can be different for classification, or it can be the similarity index. What's your objective? Then to achieve that objective, what you are trying to do. So there are GB trees, DART, I told you, right? DART. So DART is an advanced approach. You start with the basic approach, which is GB tree, because in our example, we didn't talk about dropouts, right? Dropouts is a thing that comes from the neural networks. So you first try your model as a base GB tree model, but if you are not satisfied with the accuracy, or you want to see whether DART give me better accuracy, you try DART. Okay, as I told you, DART is an advanced implementation. You can still do basic GB tree. N jobs you are already aware about. Gamma, which I told you, some loss reduction thing, so that's there. Then there is this learning rate alpha, then there is this lambda, so which is the alpha is the learning alpha. One second. Don't look at this alpha right now, because I think there is some problem, because it's saying both. Okay, alpha and lambda. Okay. So here this alpha is not specifying the learning rate, rather what it's specifying is whether you want to do L1 regularization or L2 regularization. So if you want to do L1 regularization, which is lasso, you can put the values here. If you want to do rate, you can put the value here. So if you put, say, values for both, it will be doing elastic net, the combination of both. Let me check where is the learning rate. Yeah, okay. So learning rate is here. So learning rate, which we normally say alpha. So here he is saying eta. So it's eta. So don't get confused with it. But its learning rate is not alpha, it's eta. So all the hyperparameters are here. I have just copied all the parameters from there. The important ones that you should know about is, where is that? Yeah. So the important ones to consider is the learning rate, which is 0.3 we have set up, which decides the contribution of each tree, right? It decides the contribution of each tree. If I go into that, okay. If I go over here, yeah, in that XGBoost model, if you implement, वहाँ पर भी eta था. So that eta is the learning rate. Just to tell you, an objective, as in what is your objective function, what you are trying to do. And the another problem why our initial model failed, we didn't had binary classes, we had multi classes. Means ये model भी चल जाता, but the problem is we gave binary logistic, right? So वो binary logistic की वजह से confuse हो गया. हमें इसको OVO, OVR types में पास करना होता, multi class logistic, तो वो चल जाता. वो वहां फेल हो गया था. If you remember that error, जो अभी आप लोगों को आ भी रही होगी, कि भाई your labels are not what it's able to understand, because you are saying binary and it's getting multi-class. Okay, so we can implement this also. This is very easy to implement, but we'll talk about this in a while. So what we are going through is the standard approach. So ideally we should follow this approach which I'm showing you. You first import the XGBoost classifier or regressor or ranker, and then pass on the hyperparameters in this object. Okay, learning rate, which is nothing but your eta. So let's type in eta. These are tree level things, the max depth and all. These alpha and lambda here are regularization parameters, and if you see here now, it's multi, right? So since it's multi, it's running, but if I change it to also binary logistic, it will also fail. Okay, so I change it to multi. If I change this thing here also, that implementation would have also executed. Okay, nevertheless. Okay, and then subsampling and all, which we talked about, 100% as in use entire data for every model, every tree. Gamma is also which I told you. GPU -1 as in don't use GPU as in GPU है तो use करो, वरना कोई problem नहीं है. -1 का मतलब वो ये है. अब क्योंकि मेरे सिस्टम में GPU नहीं है तो it's fine. So these are some of the important parameters. Like max depth is definitely one important thing. N jobs, N estimators, these are important. Random state is important. So most of these parameters which are there are important. And this verbosity. Verbosity as in जब मॉडल पीछे चलेगा तो अगर इसकी वैल्यू verbosity की 0 से 3 के बीच में होती है 0 का मतलब है मुझे कुछ मत दिखाओ पीछे क्या हो रहा है, 1 मतलब थोड़ा सा इन्फो दो, 2 मतलब थोड़ा ज्यादा, 3 मतलब पीछे जो भी हो रहा है एक एक चीज प्रिंट करके दिखाओ। तो हम 3 यूज करेंगे, या ट्रू फॉल्स नहीं चलता। ओके सो okay, there was one more error which I faced right now, which is this. Yeah. Okay, so while I was executing this, it was failing because of this NaN thing. So missing values are denoted by what? NaN. Okay, that's fine, but what is NaN? System does not know that. So what I have to do is I have to define NaN. So I have to import numpy as np, and numpy has NaNs, right? So I did this. So if you don't do this, it will fail. So I'm just saying NaNs are numpy's NaNs, as in not a number or a null, whatever. So this you need to do separately. Otherwise ये यहाँ पे fail हो जाएगा NaN इस point पे. या फिर आप ये भी कर सकते हो, आप यहीं पे ही np.nan यहाँ पे भी लिख सकते हो. That's also fine. Okay, you don't need all this stuff. So I'm going back to the basics. I'm not using the one which was copied from that website. Yeah, perfect. So this is what how you work in sklearn is similar to that. From XGBoost, import XGBoost classifier or regressor, whatever it is, create an object of it, but this is most important, right? Whether you are doing a binary classification or multi-class classification, that needs to be specified, otherwise you will get errors. क्योंकि रिग्रेशन के केस में तो ये XGB रिग्रेसर होगा, वहां कोई टेंशन नहीं है. क्लासिफायर के केस में आपको अपना ऑब्जेक्टिव बताना पड़ेगा, what's the data is, वो बाइनरी है या मल्टी क्लास है. And then come back to this, which is simple. अब यहाँ पर आपको ट्रेन टेस्ट स्प्लिट करना पड़ेगा, जैसा हम sklearn में करते थे ट्रेन टेस्ट स्प्लिट प्री प्रोसेसिंग में, तो वो मैंने किया है दोबारा से. And then I'm passing the X train and Y train, and this verbose actually is not that important, but yeah, because the verbosity हमने ऊपर सेट कर दी है, so I'm just fitting this model and let's see what happens. And even before that, let me do this import time and time dot time, that is like say start time, and then say end time is equal to again time dot time, and I'm saying end time minus the start time. Okay, so let's see what happens here. So here the model is running. You can see this is all what's happening at the backend. And finally 0.56 second it took, because records बहुत कम है हमारे पास. That's one thing, how much time it took, but what's happening here, this is important, right? So let's see this. So it's running the XGBoost model, where it first pick the random value, the base value, and then it starts to build the tree using similarity index, right? But at each tree level, what it needs to do is it needs to prune it. So here automatically it internally keeps pruning it based on the values of gamma parameter, which is like gain minus gamma, which I told you. So based on that value, it keeps pruning the tree, and just it's showing you this tree pruning ended. Okay, and there are 6 extra nodes, 0 prune nodes. So कोई भी नोड प्रून नहीं हुई है. टोटल 6 नोड इस ट्री में है. मैक्स डेप्थ इसकी 3 है. इस ट्री में 12 नोड्स हैं टोटल, 0 प्रून नोड्स, मैक्स डेप्थ 4. तो मतलब जितने भी ट्रीज पीछे बने आपको यहाँ दिख रहा है, ये पहला ट्री, ये एक दूसरा ट्री, ये तीसरा ट्री, लाइक दिस, दीज आर ऑल ट्रीज. हर ट्री जो उसने पीछे बनाया है उसकी कितनी नोड्स हैं उसमें और कितनी उसकी मैक्स डेप्थ है. That's what it's keep telling you. It keeps building those 100 odd trees, whichever we have marked, say 100 trees, and then finally it tells you like 100 total calls happened, this much microsecond it took, and the time is in epoch. The time is in epoch. Where is this epoch actually? No, this is not epoch. This is seconds. Time is in seconds. 0.5 seconds. It's not epoch. Epoch तो शुरू में देखो ना, शुरू में जीरो है. शुरू में जीरो नहीं हो सकता ना epoch में. Millions of days seconds आज तक गुजर चुके हैं, right? तो this is in seconds. तो ये आपका ट्री मॉडल जो है वो फिट हो गया, which is XGBoost model. And the important things to remember is the base score, which is 0.5. You can set this base score, or you can let it to be the default value, which is 0.5. Then this was the GB tree. You can change it to Dart. Okay. So these are the important things to remember. Gamma as in 0, GPU is there. Importance type is gain, which we were talking, right? The similarity gain that it will use. Okay, so now when I check the score, it's giving me score as 1, but when I'm doing the prediction, XGBoost.predict on the data, this is the data. Let me check the prediction accuracy. So it's 90. So 90 is the test accuracy here. Now let me change a few parameters, as in दोबारा से अगर आप अपने माइंड में याद रखो कि XGBoost मॉडल कैसे चलता है, कि भाई एक बेस वैल्यू है, उसके बाद जितने भी ट्री बनते हैं सब में एक लर्निंग रेट रहता है. तो लेट चेंज द लर्निंग रेट टू 0.1 फॉर एग्जांपल. Learning rate as in eta. Okay. After that, all the trees are built using similarity index, and importance is by gain. That's fine. This is for individual trees, right? But overall, finally, what will happen? Do you want the GB trees or you want Dart? Let me say, okay, I want Dart, which is advanced approach. Okay. Do you want to pass on the entire data to each tree, which is actually bad, right? Because that's why you might be getting this as 100% prediction accuracy. Let me say, let's do 0.9. I want only 90% of the data to get passed while training each tree. Okay. So save it, run it. So it's just running. Okay. So monitor the learner. This is the cause. So okay, so my learner is there. I created the object. So now I'm just fitting it. So this tree is getting 100 trees are being built. Each tree is being pruned, and further this took more time actually. If you see 94 seconds, 0.94 seconds, sorry, 0.94 second. Let me check what happened to this, but still this is still 100% accuracy, no problem. Let's see if my prediction accuracy is improved or not. So earlier it was 90. Okay, let me note it somewhere. So earlier it was 90. Now what it is? So it's still same. Okay, nothing much happened. Let me go back. So nothing much happened here. So let's try to change the subsampling to say 8, like, and now let's put on the regression, as in we have given L2 regression, right? But let's say I also want L1 regression also, which is like those features which are not important, completely ignoring those, and let me do this 0. So now I'm doing the regularization, L1 regularization, right? So this is L1 and this is like L2. Save it. Let's run this, and now see what happens. So this will converge more. It will try to converge more, right? It will try to panelize more, so it took more time. Okay. Still, it's 100% accuracy. It's fine. Let me see the prediction. What happens to that? So it's not changing much here. So the scope of the improvement in the test data, the problem is we have very limited test data also. I think how much, very less data. Okay, so you can try it on a bigger data, and when you change these values, currently you are not seeing any difference, but then you will see that different. यहाँ तो 200-300 records ही हैं. And another thing important is XGBoost and these kinds of models should not be used on the smaller data. Rather, they should be used on the higher data, the bigger data, like 10,000, 20,000 records minimum, because then it gives you a better performance, better accuracy as compared to the normal model. Give me 1 minute. Let me just try it out on the bigger data set. Yeah. So this is where we have lakhs of records. Let me just try it out. So here we have around, I think, 2 to 3 lakh records. So this base model will work better there. Okay. So let's just take this out. Here. Put it over there. Okay, so the data is loaded. I'm just doing certain cleaning aspects. Okay, so this is cool. This is perfect.
Excuse me, sir.
One second, Aditi. 1 second. Wait. Yeah. So this is the train test split, which I need to do. So just splitting it, and now let me just paste it. 1 second, Aditi. Let me just paste the code here, and then you can ask question. But here definitely it will take too much time. Yeah, done. Yes, Aditi, tell me. X mode is not defined. Okay, I'll do that. Yeah, Aditi, you're saying something.
यस सर. सर जो हम डेटा को, जो पिछला वाला जो डेटा सेट जिस पे आप ये चला रहे थे, तो उसमें
Yes.
हमने क्या किया है, डायरेक्टली कुछ जो पहली रोज है वो हमने ट्रेन में डाल दिया और कुछ लास्ट की जो है हमने टेस्ट में डाल दी. तो क्या उससे क्लास में इम्बैलेंस नहीं हो गया होगा अगर सारी लास्ट की रोज में सिर्फ क्लास 1 या 2 हो? मतलब क्लास इम्बैलेंस की वजह से भी तो ओवरफिटिंग अंडरफिटिंग होगी.
Definitely.
तो हो सकता है कि उसकी वजह से ये रिजल्ट्स नहीं दे रहा.
No. Okay. Your thought process is absolutely correct. What you thought is absolutely correct. But what I said is, now I am not using this. Actually, Aditi, I'm not using this. Okay. So I'm not using this approach. इस approach के लिए मैंने वो किया था, जो पहले 120 records और 50 records split कर दिए थे. But then I went away from this approach because यहाँ पर वो क्यों फट गया था? Because objective was binary, our data was multi-class, right? So, but yes, whenever you do that kind of shuffling, that's the problem. That's why it's not good. वो तो just to tell you guys, to implement this, I was telling you, just to bring that data in this format of train and test. But yes, you should never split in the order, like first 100 or first 80%, next 20%. It should always be based on some sampling approach. Either it's like test train split that you do. It should be using that only. Okay. तो हम आइडली क्या कर सकते हैं? आइडली आपको क्या करना चाहिए? लेट मी टेल यू. फॉर एग्जांपल, मान लो आपके पास ये डेटा है, ठीक है, और मतलब वो फीचर्स हैं और ये आपका टारगेट है, ठीक है. सो दिस इज योर फीचर्स, दिस इज योर टारगेट, बट फाइनली यू नीड डेटा इन दिस फॉर्मेट, राइट? यू नीड डेटा इन दिस फॉर्मेट, ट्रेन एंड टेस्ट फॉर्मेट, जिसमें एक्स और वाई दोनों साथ में हो, राइट? तो you simply first of all pass on this data through the train test split, like sklearn dot pre-processing. You have sklearn dot pre-processing, right? So just pass on this data in there. You will get 4 sets, A, B, C, and D out of it, right? Once you do the train test split on this, you get 4 data sets. Let's say this is the X and Y for the train, and say this is the X and Y for the test. Okay. So after doing that split, then you should ideally concatenate. तो जो concatenation देखो हमने क्या किया, हमने ये दोनों ऐड कर दिए, concatenate कर दिए, और उसके बाद हमने उसको मैनुअली स्प्लिट किया, राइट? तो वो सिर्फ क्लास में करने के लिए ठीक है, बट रियल वर्ल्ड में कंपटीशन में आप वो सब नहीं कर सकते. रियल वर्ल्ड में आप क्या करोगे, ये 2 सेपरेट डेटा फ्रेम्स को एक्स ट्रेन एक्स टेस्ट के थ्रू पास करोगे, लाइक दिस. Where is that? Yeah. So this is what you have to do, Aditi. Like if you have in future, if you have like this and these 2 data sets, you will simply pass it here in the train test split. You will get these 4 data sets, right? So after that, you can concatenate this and this and this and this. You can concatenate these. तो दिस इज बेटर बिकॉज इस केस में वो जो आप कह रहे हो बिल्कुल सही बात है कि क्लास इम्बैलेंसिंग वाली प्रॉब्लम भी अवॉइड हो जाएगी. सो फाइन अदिति. सो इन आवर केस that could have been the problem if if we would have used this, right? That would have been the problem because यहाँ पर हमें सिर्फ ट्रेन और टेस्ट डेटा देना पड़ता है. तो इसीलिए I didn't went ahead with this approach. Rather I went ahead with the standard approach which we do in the sklearn. तो यहाँ पर अगर आप देखोगे अदिति, what I did was I'm passing the X train and the Y train. So ultimately I have splitted it using the approach we have been using so long, which is this one. Let me put it there. So if you see Aditya, I have commented all these things, right? Which I did. I've commented all those stuff. I'm not doing this.
Yes, sir.
Okay, so I'm doing this only actually. Okay, so this is only what's happening, but still the problem is because data is like 120, 130 records, still you're not getting that good results. Okay, and also changing the hyperparameter is also not giving you any change. But now let's see it on millions of records. Okay, so now what I will do here is I have some data. This is my data. So I'm splitting it. तो पहले क्या है, यहाँ अब जो मैं डेटा ले रहा हूँ वो फिर से वही है, फ्रॉड डिटेक्शन डेटा है, जहाँ क्रेडिट कार्ड ट्रांजेक्शन्स का डेटा है और हमें उसे फ्रॉड और नॉन फ्रॉड में कन्वर्ट करना है. तो अब यहाँ पर हम मल्टी की जगह बाइनरी डाल सकते हैं, बट लेट्स सी कि अगर हम मल्टी भी डाल देंगे तो क्या होगा. फेल होगा तो हमें पता है कि क्या करना है, बट दैट्स अ डिफरेंट थिंग बिकॉज हियर इट्स ओनली 0 and 1, the negative and the positive class. So I am just creating this data. It's saying this X mode is not it's not understanding this X mode. Okay, so let me go back to the root data. Where is the data? Okay, 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 okay. This is the amount and the class. Okay, okay, perfect. So let me take this data frame only there, guys. Okay, so what I need to first of all do is I need data. So df is my data. So this is my data where I have some features and then I have a target. Okay, now I need to split it, right? I need to split it using this proper approach. Okay. So since I need to split it, I need data in the form of X and the Y. So as I did yesterday also, you guys remember, I created say X and then Y, where X equals to df dot drop. मतलब आपका डेटा किसी भी तरह से हो सकता है, तो आपको उस हिसाब से अपनी हैंडलिंग अप्रोच चेंज करनी है. आपको ड्रॉप करना है क्लास कॉलम फ्रॉम द एक्सेस 1 एंड देन आपको यहाँ पे सिर्फ सिलेक्ट करना है क्लास कॉलम. दैट्स इट. We have X and Y now done, so we'll pass here X and Y, and we'll get our split data. Okay, so the splitted data is available to me. Now I'm running the XGBoost classifier. So my XGBoost classifier is just built. Now I'll pass on these data sets there. Yeah, so here the data is this and this and this. Okay, so abhi I'm training my model to learn the pattern for detecting the frauds in the credit card. So fitting a model is just training it to learn the patterns in the data. So it's learning the patterns. So let's see what happened. Value 0 for the parameter num class should be greater than equal to 1. Number of output classes. See, so that's what I was talking about. This time it failed because multi class कर रहे हो, binary मतलब binary के लिए multi class करने की कोशिश कर रहे हो, तो it failed. Okay. So what I need to change here is change it to binary, and let's say logistic, as we had here, right? Binary logistic. So I'm running this. So so now this model is getting trained. If you see here, because now data is too much, it's taking time. पहले तो 1 सेकंड में उसने दिखा दिया था सब कुछ. Now each tree is being built. At the same time, it's being pruned. Okay. The trees are getting built, and at the same time pruning is happening, and finally उनकी depth sprint हो रही है आपके पास. It's just kept doing that. Now 100, you consider it will take 3-4 minutes minimum. So here ideally the what happened? कहाँ गायब हो गया? आप विंडो का साइज बढ़ा सकते हो. इन pandas there is a set options. आप इस विंडो का साइज बढ़ा सकते हो. ये अभी स्क्रॉलिंग विंडो बन गया है, बट आप इसको चेंज कर सकते हो. So as you can directly see now, it's bidding trees, and parallelly it's like pruning them based on the lambda and the gamma. This CC here is means it's a C. It's written in C, C++. Okay. So most of the Python packages are written in C, C++. So backend, if you want, I can open this code. If you go this path, okay. If you get this path, and if someone of you know C, C++, what happened? बाकी लोग भी प्लीज रन कर लो इसको। जो आपने पहले चलाया था उसी में बस वो बाइनरी को मल्टी कर दो, it will run. So just change this binary thing to multi and soft prob. So let me ping you. Soft probability is something that we need to pass on. Just change this, okay? Change this and it will run. So if you guys still want to use this, just change this and it will run. But if it is not, then I will upload my code in some time. You can use that. So ideally you should use that only. Yeah, I'll upload it in some time after the class. But see, earlier guys, we used to use this only. But अभी क्या हुआ है ना, ये नया format है actually. Just to tell you, this is a new format. Even जो light GBM वगैरह भी अभी आप देखोगे, वो इसी format को follow करते हैं. ये sort of नया format है जिसमें हम parameter अलग declare करते हैं and then train it like this. But I personally follow this, the older way. But yeah, this is also there. This is a newer way of running these. Let me check if it's completed or not. Yeah, so it took 190. So if you see, it took subsequent amount of time, but still my features were less. Consider in real world you have 100 to 1000 features. Normally we have thousands of features in real world. Millions of records and thousands of features. So it will take hours to run. Okay. So now we are done with all these things. Let's just see its accuracy. Okay. It's capital X, so that's why it's failing. So now it's a bit better. Okay, 99.98. So I can still relax that, okay, it's not overfitted, though it's still not that good. Now let's see what's happening for this. So now I'm checking the test accuracy. For that, first I will do prediction and then I will run this. So I get my output here and then I'm just checking what's this SQL accuracy, it's X mode and okay, I can check that later, but let's see what's the problem here. Classification metric can't handle a mix of continuous multi-output and binary targets. Continuous multi-output and binary targets. Where is the binary targets? Prediction. Okay. I think I need to just see what's the data is inside it and what's the data inside it, and I have to just compare these. Oh, sorry. My bad. It's Y. Yeah, sorry. What I was doing, I was passing X. I think no one noticed that. I was passing X, so it's Y, right? So Y test and the actual prediction. So 99.97 is what the accuracy. So 99.98 and 99.97, which is pretty good. That's too in such a huge data. So this is really a good model. Okay. Because on 1 million records, if this is the performance, it's good. Okay, I'll share all these codes, but let's move ahead in the time being. We have to complete 2 more topics. So now we will talk about the light GBM and the CAD boost. So let's see what's there. Okay, so these links are quite good, guys. You can use this latest syntax also. It's perfectly fine. But now moving on to the light GBM. So what's the difference? Okay, so light GBM, as the name suggests, it's further enhancements on top of rather what XGBoost was doing. Okay, it's further far better. Light as in it's lightning fast. Light as in it's lightning fast. It's very fast as compared to even the GBM. GBM से कंपैरिजन में तो बहुत ही फास्ट है, बट XGBoost से भी कंपैरिजन में किसी किसी केस में अच्छा है. दूसरी बात, ये भी तभी यूज करना चाहिए जब ह्यूज अमाउंट ऑफ डेटा हो हमारे पास, और ये भी प्रॉपरली मेमोरी वगैरह को अच्छे से हैंडल करता है. ये माइक्रोसॉफ्ट ने स्टार्ट किया था प्रोजेक्ट, दैट्स व्हाट इट इज. एंड इंटरनली वही सारी प्रोसेस है, एडिटिव मॉडल है, डार्ट है, मतलब ऑल दोस थिंग्स, ड्रॉप आउट्स एंड ऑल. Few things to remember, 2 things rather to remember here is 2 things to remember. One is it supports GPUs. Okay, so when I say it supports GPUs, so when you do pip install of light GBM, so that by default only supports CPU. So if you want the GPU version of the package, you have to install a separate package of light GBM, which is just to mention, while you do install, you have to mention that you want the GPU support. So that's there, but default version does not support the GPU. That's one thing. The second thing here is the way the tree is built here is a bit different. Okay, so why it's faster as compared to XGBoost? Mostly it's similar to XGBoost, but the way it builds the tree, that's different. Okay, so instead of building the tree level wise, it builds the tree depth wise. So what I mean to say here is this. This link and YouTube videos you can go through. 1 second. No. This. Okay. So this is Microsoft LGBM light GBM model. So if you see this one, the green dot says what is being built. First this is built, then this is built, and then this is built. Okay. But here it's like first this is built, then like this is built, it's building this, or it's building this, and then it's building this. What I mean to say is, again, breadth first search and depth first search again, right? So this is like first you build this node, then you build these 2 nodes before you go to the next level. Okay, in XGBoost. But in the GBM, you build this, you build this, you further build next. So you keep going down, 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 unless you are satisfied that now I should stop. And then you come up, you build the other sides of the tree, you build other sides of the tree. So here you are doing DFS, or depth first search type of processing. It's not actually depth first search, but it's depth first search type of processing, where here you are doing level wise, tree is growing level wise. Okay, here tree is growing leaf wise. So here first level will be built, then second, then third. But what these people have identified is building tree in this way is better, both in terms of performance as well as in terms of accuracy. So they went ahead with this. So what they have identified is, see, you have a loss function, right? Ultimately, it's all about loss function. And it's the reduction in the loss function that you want, right? The gradient thing. So the reduction in the loss function is better. Okay, it's better when we grow tree leaf wise as compared to when we grow it level wise. So that's the whole purpose here. And definitely here, one thing which is very important is to set the max depth, because otherwise lot of chances of overfitting. Okay, so because it's going depth first, right? So you have to specify that, okay, don't go up till like more than 5 or 6 depth. Okay, so in light GBM, if someone asks you which is the most important hyperparameter after definitely after the loss functions, next depth is the most important parameter. And why? Because it's a depth first search type of a processing which builds the tree leaf wise rather than level wise. Okay, so that's the difference that I want to tell you. Not much is there to consider here. Let's quickly see the implementation here. Again, you have so अभी तुम लोग अगर ये देखोगे दिस XGBoost, राइट? ये जो इम्प्लीमेंटेशन XGBoost का है, ये इन लोगों ने इसलिए नया इम्प्लीमेंटेशन दिया क्योंकि जो लाइट GBM है, लाइट GBM का इम्प्लीमेंटेशन एक्चुअली ये वाला है, नया फॉर्मेट। तो इसीलिए आप पहले XGBoost पुराने फॉर्मेट से सीख लो, उसके बाद नए फॉर्मेट से भी चला लो। नया फॉर्मेट भी तो ज्यादा इजी है, बल्कि दिस इज फास्ट, मच इजियर टू रिमेम्बर। Okay, so that it will help you to run the GBM. So let's see, let me copy this parallelly to explain you both. If I put it here, so if you see here, similarly, like you don't need to call a classifier separately, regressor separately, कुछ नहीं करना आपको। मॉडल विल सी कि भैया टारगेट वेरिएबल क्या है। टारगेट वेरिएबल अगर नंबर है तो वो खुद से रिग्रेसर को कॉल करेगा अंदर इंटरनली, और अगर वो कैटेगोरिकल है तो वो कैटेगोरिकल काम करेगा। ओके, या फिर देयर आर सम प्लेसेस वेयर यू कैन मेंशन दिस कि भैया तुझे करना क्या है। मतलब एक तरह से आप ऑटो एमएल की डायरेक्शन में जा रहे हो, जहां डेटा देख के ही पता लग जाता है कि करना क्या है। बट स्टिल ये ऑटो एमएल नहीं है, इसलिए यहाँ आपको अभी स्पेसिफाई करना पड़ेगा। ओके, क्योंकि यहाँ पर आपको ये तो स्पेसिफाई करना ही पड़ता था, ये बाइनरी लॉजिस्टिक। मतलब बेनिफिट तब है जब आपको ये भी स्पेसिफाई ना करना पड़े, और वो सिर्फ टारगेट को देख के ये पता लगा ले कि ये बाइनरी है तो मैं ये लगाऊं, लॉजिस्टिक है मल्टी क्लास है तो ये लगाऊं, अदरवाइज मैं क्या करूं। बट ये अभी उतना स्मार्ट नहीं है, ठीक है। ओके, सो इफ यू सी, यू इंपोर्ट द GBM एंड नाउ यू आर नॉट calling classifier or regressor separately, you are simply saying lgb.train and you are training it. Okay, training it on what? Your train data. So here is your train data. So lgb.dataset. So like ऊपर आप दो मैट्रिक्स बना रहे थे अलग अलग, ट्रेन का टेस्ट का। ये और स्मार्ट है, ये कहता है एक ही डेटा सेट बताओ, उसमें ट्रेन और टेस्ट डाल दो, सॉरी फीचर्स और टारगेट डाल दो। ये आपके फीचर्स हैं, ट्रेनिंग फीचर्स, और ये ट्रेनिंग टारगेट। लेबल आपने यहाँ कर दिया इसको, ये आपका लेबल है, तो वो समझ जाएगा कि इसमें से कौन सा आपका X है और कौन सा आपका Y है। सिमिलर अगर यहाँ देखोगे तो पैरामीटर यहाँ पर भी है, तो पैरामीटर यहाँ पर भी है, वहां पर भी पैरामीटर डिक्शनरी के फॉर्म में है, यहाँ पर भी पैरामीटर डिक्शनरी की फॉर्म में है। आई होप सबको ये तो क्लियर ही है। ये अगर ये डिक्शनरी है तो डिक्शनरी डॉट की और ये की वैल्यू, तो आप ऐसे सेट करो या फिर आप इसको ऐसे सेट करो, एक ही बात है। इसने ज्यादा थोड़ा और इंटेलिजेंस दिखा दिया है, आप ऐसे सेट कर दो। दिस इज वन एंड द सेम थिंग, यू डोंट नीड टू डू दिस। ओके, जो कि इसने यहाँ ऊपर किया है, तो ये भी एक तरीका है, ये भी नीचे वाला भी एक तरीका है। ओके, बूस्टिंग टाइप वही GBDT, डार्ट, आप सब ट्राई कर सकते हो, ये तो बूस्टिंग का टाइप हो गया। बट मेट्रिक क्या यूज होना है, वो आपका ऑब्जेक्टिव क्या है, मतलब बाइनरी है या मल्टी है, और उसमें भी फिर बाइनरी लॉग लॉस, सब फीचर्स कितने हैं, मैक्स डेप्थ विच इज मोस्ट इंपॉर्टेंट, मिन स्प्लिट, मिन डेटा, मिन बकेट, नंबर ऑफ लीव्स, वो सारे फीचर्स। तो बात सेम ही है, बट इंप्लीमेंट करने का तरीका अलग है। लेट मी रन दिस, बट अगेन see it's running light GBM. Number of positive classes and number of negative classes, it's telling you in the data. Your data is having imbalance problem. Immediately you can see this without doing much of EDA. Okay, so it's giving some info, some warnings, may give some errors. Number of data points in the training set 124. Number of used features is 13. Start training from score this, the initial score, no further splits. So it's just start to build the trees. Again, it also needs some initial score or the base score, and then it keeps building the tree like you talked in XGBoost. Not much to see here after that. Okay. Then we'll predict it. This is the predicted values, but here it's probabilities. It's predicting not 0, 1, 0, 1. It's predicting the probabilities of the positive class. So what I can do is I can convert it into zeros and 1 using this thing. That if this value is greater than 0.5, make it 1, else make it 0. Y predict is not defined because I haven't assigned this data to Y predict. This output I haven't assigned, right? So I'll assign it to Y predict, and let me just run it. Index 54 is out of bound, X is 0, fifths. Okay. So total records kitne hain? Let me check. Total records are 54, but I'm running the range up till 99. I should run it till 53. So index out of bound error आप लोगों को पता ही है, right? तो मैं out of bound चला गया था because मैं 99 तक रन कर रहा था उसको. So now I ran it. It's done. My values are now converted instead of probabilities into the actual 0 ones. So if you see here, this is okay. What's this? Why this happened? I'll check why this happened. So ये तो सब कुछ पॉजिटिव क्लास को प्रेडिक्ट कर रहा है, तो यहाँ क्या होगा? 1 second. So we'll check the data why it's doing so, and we can also plot the confusion matrix to see कि वो true positive true negative ये actually आ क्यों रहा है. Is it because of true positive true negative or what's the reason? So let me just check it. Okay. जब भी इस तरह की प्रॉब्लम आए कि सब कुछ 1 या 0 दिख रहा है, तो ट्रू पॉजिटिव ट्रू नेगेटिव वो हमें देखना पड़ेगा. ओके नितिका, what was the shape? 54. Okay, yeah, Nitika, thanks, very good. Thanks a lot for noticing that. But I think it should be 54 here. Yeah, you're correct, Nitika. Means not 55, but yeah, 54 because this is inclusive of the range. But you're correct. I missed one of the observations. For I in this, if you print I, so it goes all over up till 53, 0 till 53. So if it's 54, I have to put it 54 because it goes 0 to 53. So that's what, yeah. But why it's not going up till the last record? Okay, we'll check this. What's the problem with this guy? This last guy is left. Let me check this. So guys, I'm just checking why this last guy is left here. So 53. So 53 is actually this value, right? 54. Yeah, so nothing is on 54. So why it's not going to 53? So thanks for my 55. Guys, can anyone tell me, I may be missing it something in the rush? Why I'm not able to capture this? Am I doing some mistake? Why the last record is left? The range 0 to 55 will work. No, Pragesha, actually 0 to 55 will not work because 0 to 54 means last element is 53, right? That's why. It's covering 53. Maybe something. Oh, okay. Oh, sorry. I think who was that? Aditi. Oh, Aditi. Thanks a lot. Thanks a lot, Aditi. I was not running that. I was just referring to that. Yeah. So thanks. Thanks, Nitika. You to point out the main issue. And yeah, now it's good. But the problem is it's predicting everything as one. It may be because the data was the problem, but I don't know, right? Let's check the confusion matrix. Because in such cases, the confusion matrix is the one that helps us import Seaborn as SNS and SNS dot heat map and pass on the CM element there and see this. So import Seaborn as SNS, SNS dot heat map, pass on the confusion matrix. Why it's taking too much time? Oh, okay, it's running on this. So it will just come up 1 minute. What's this? New things every time. Oh, okay, it's a multi-class classification now. Okay, it's multi-class, that's why this is where the confusion matrix is. Okay, so I think this is better. This is better what we should look at. And probably, guys, the another problem that this is multi-class classification, right? 0, 1, 2, 0, 1, 2, like that. And definitely there are errors because of this thing, these are all errors. But the problem might be because data was multi-class, but what we did above was the C. We said binary, right? So what it must have done is taking everything as one class and remaining as another class. So we should convert it into multi. Okay. So let's check this. So light GBM throws an error. So it does not understand multi. So what we have to do is we have to open up this. Okay. So when you don't know the hyperparameters, the best thing is open the thing and go inside. Check what it understands for multi. So it also has the classifiers and regressor. Okay, so I could have used this also, but just to check the value, I'm just referring the older approaches because they are the best. New approaches are not user friendly actually. So from this, you import this and create an object out of it, or just pass on this as a reference. So yeah, so here I can check that value. Where is it? The boosting type is the Dart or GBDT. But where is this? Yeah, objective is none, right? Objective is none. So let's check what the objective is. Okay, so it's multi. Okay, we have multi log loss. Okay, let me put this multi log loss there. But I also need to check the objective. Okay, what's the objective? Okay, so we got to know the possible value and why the problem is. So let's pass on that value. Let me pass this as this, and let me not pass this. Okay, or rather, let me comment it out. What's the problem now? Okay, so multi-class objective and matrix does not match. So if you see now, so make sure that you keep looking at the error one by one. Okay. So what happens is there is one objective and there is one metric. So objective and metric both should match. I said multi log loss, but here it didn't understood what you actually mean. Okay. So this was binary. Let me try this because I also don't remember right now. It's multi or multiple. Let me try multiple. Okay. So for this, then you can go back to this place, come here, glide GBM, come here at the features. Okay. So this documentation will help you. Control F, let's check for objective. So you have some objective here. Okay. Let's check what's the value of the objective. Okay, so binary classification, the objective is log loss. Then for regression, the objective is L2 loss, then supports, okay. So it supports multi-class log loss, but I'm not getting the exact value, cross entropy, non-binary labels. Okay. Guys, can anyone simply Google it out immediately and tell me whether it's cross entropy or it's multi-class? What should be this word actually? Just tell me the word and I'll put it there. Okay, got it. Thanks a lot. So who pinged me? This Nishtha. Thanks, Nishtha. So okay, so I was putting multi or multiple. It's multi-class. Okay. And let me just copy this thing which someone pinged me, right? So you no, still it's not running. The number of classes should be specified and greater than 1 for okay, good. So whenever it's multi-class classification and you are doing this, you have to specify the number of classes. So let me first of all put this. These are all the possible values of that type. I'm putting it as a markdown. So I also need to specify the number of classes here. Okay. So what I'll do is, so whenever it's binary classification, to simple hai kaam. Multi-class mein you have to just write multi-class log loss, and then the number of classes which are there. So we have 3 classes, right? So I'm just looking at the parameter to specify the classes. Okay, let me check it. So the best way to do all these things is let's go to this path instead of putting any efforts. Go to this path. Meanwhile, you can Google to specify the class in LGBM. What is the hyperparameter name? That's what the problem with the new approaches is. Control H. They are not that friendly, and you have to open up these things again and again. Okay, so I'm opening the file. I'm opening the backend file to show you the actual code. Sorry, I actually executed the code. So if you run this, it will execute the code. Okay, so yeah, so this is the site packages light GBM folder. So if I go inside this, here I will be able to see that parameter. Multi-class classification application, multi-class classification. Yeah, Pratisha, that problem is solved. Thanks a lot. That problem is solved. But now the another problem is whenever you have to specify some multi-class classification, आपको number of classes भी बताना पड़ता है. So I'm just looking at that parameter at the backend because it's failing, right? So why it's failing? So to debug that, I'll tell you how we can do that. See, for example, हम लाइट जीबीएम कर रहे हैं या कोई भी मॉडल कर रहे हैं, हमने उसका हाइपर पैरामीटर्स बता दिए बिकॉज ये बाइनरी नहीं है, मल्टी क्लास क्लासिफिकेशन है, उसका लॉग लॉस भी मल्टी लॉग लॉस है. बट नाउ इफ यू लुक एट द एरर, ओके, you see the number of classes should be specified and greater than 1. So where the error came from? So how we normally debug is just look at this debug string. This arrow is raising this error. Okay, then why this error came is because of this arrow, which is this brace. But why this error came is because of this arrow, which is this. Okay, so it may be the params string, it may be data, it may be refs data, I don't know. So then I'll go further up and then I'll see this. So this is the arrow, so this is the error. Categorical feature is equal to self feature and whatever params and self.params. So that's one thing. And then if I further go inside this, so this is the construct. So I'll open this construct and then this is the place where the error arises.
So,
yeah.
So,
Yes, tell me.
Sir, actually, when the objective multi-class is mentioned, there are some more parameters that need to be mentioned, like num class and multi-class OVA. Yes.
Yeah. That's what I was. The number of class. That's why it's failing, and absolutely, it's failing because it's saying number of classes should be specified and greater than 1 for multi-class training. So I'm asking you to Google it. I'm trying to look in the backend code and I'm asking you to Google it. But someone pinged me, I think. Let me check. People pinged me already. So num class is equal to say 3. So thanks, Vipul. So it all depends upon the data and all. So if it's binary, it was simple. But if it's multi-class, the additional thing that you have to add is this number of classes. I'm putting it. Okay. Yeah, Gulzar, you have any question? Guys, anyone, any question?
Excuse me, sir.
Yes, Gulzar, go ahead.
एक्चुअली बीच में भी कोई ऑडिबिलिटी इशू आया था. आपने मल्टी क्लास की कौन सी बात थी जो आपने गूगल करने को कहा था?
हाँ, मैं आपको ये बोल रहा हूँ कि कभी भी आप ये नए सिंटेक्स जब यूज करोगे इस तरह के, और आप जब हाइपर पैरामीटर्स की वैल्यूज चेक करना चाहोगे, तो यू हैव टू फर्स्ट ऑफ ऑल ऑलरेडी अवेयर, क्योंकि वो डायरेक्टली सारी वैल्यूज नहीं दिखाता कि भाई कौन सी वैल्यूज हैं. नाउ द इम्पोर्टेंट थिंग्स टू रिमेम्बर इज कि अगर बाइनरी क्लासिफिकेशन है तो ये 3 आपको याद रखना है: ऑब्जेक्टिव, मैट्रिक एंड नंबर ऑफ क्लास. तो मैंने आपको बोला था कि नंबर ऑफ क्लास स्पेसिफाई करने के लिए पैरामीटर या हाइपर पैरामीटर का नाम क्या है. So which people told me is this. Okay, sorry. So which is this highlighted thing. So कभी भी मल्टी क्लास क्लासिफिकेशन करनी है तो आपको नंबर ऑफ क्लासेस स्पेसिफाई करना है. और एक बार हमने ये कर दिया, अब हमारा मॉडल ट्रेन हो गया। तो अब मैं एक बार दोबारा से इसकी आउटपुट देखता हूँ, whether this time it's better or not. Let me do the prediction. See, this time it's good, right? Earlier it was not good. Now it's 3 classes and the probabilities are split across 3 classes, 0, 1 and 2. So in this case it will predict this, right? So that's how it's now giving me the output, and now I can change this if then else accordingly. Okay, but in this case the problem is I cannot use this. See, I cannot use this now because यहाँ 3 वैल्यूज है मेरे हर एक एलिमेंट के अंदर। तो इस केस में मुझे क्या करना पड़ेगा, मुझे आर्ग मैक्स लेना पड़ेगा, आर्ग मैक्स ऑफ दिस, and then I'll put this value like that, and yeah. Okay, so argmax is not defined, right? So import numpy as np and say np dot argmax, and then let's see. So now if you see, अभी भी कुछ गड़बड़ है। गड़बड़ क्या है कि मैंने उसको वाइब्रेट में ही लोड मार दिया। बताता हूँ मैं आपको, एक सेकेंड, आई एम टेलिंग यू व्हाट टू डू। सो देखो, अभी क्या हो रहा है, आपके पास मॉडल ने जो प्रिडिक्शन दिया मल्टी क्लास क्लासिफिकेशन के केस में, मॉडल इस तरह से प्रेडिक्ट करता है, मल्टी क्लास क्लासिफिकेशन नॉर्मली इस तरह से प्रेडिक्ट करता है, ठीक है। अब मुझे क्या करना है, मुझे इन सब में से जो मैक्स वैल्यूज हैं वो लेना है, राइट, एंड दैट्स इट। सो अभी आप देखोगे तो आउटपुट आ गया, बट इसमें थोड़ा गड़बड़ है। मैं उसको भी सही कर देता हूँ, एक सेकेंड, सो व्हाट आई एम सेइंग इज कि मुझे जो भी मल्टी क्लास क्लासिफिकेशन में आउटपुट आता है वो तीनों क्लास की प्रोबेबिलिटी आती है, मुझे इसमें से एक्चुअल में देखना है कि वो कौन सी क्लास को बिलोंग कर रहा है। तो मुझे बस एक सिंपल सा यहाँ पे फंडा लगाना है कि कौन सा इसमें से मैक्सिमम रिकॉर्ड है, जो हमने पिछली बार भी बात की थी, तो वो argmax वाला फंडा था, सिंपल। सो लेट मी जस्ट प्रिंट दिस वैल्यू, ये मुझे इंडेक्स दे देगा हर एक क्लास का। या करणदीप, यू आर करेक्ट, सो दिस इज हाउ इट्स द आउटपुट। So yeah, Karandeep, thanks for the point. And I can assign it to a new array that's onto me, but yeah, this is how the output is. And once I have this output, I need to assign it into a new array, so I can create an empty array. Okay. Say I can create an empty array. I'll create an empty array and I'll pass this element into the array. Array of I is equal to this list index assignment out of range. One second. So what I am trying to do, I'll tell you first of all, simple. मेरे पास आउटपुट तो आ गया है, बट अब उस आउटपुट को मैं एक नई एरे में सेव करना चाहता हूँ, दैट्स इट। Actually, there are a lot of functions, guys. So there are a lot of functions for array, list, and index. Yeah. So now I have the data in a single array available to me. Now I'm just trying yeah. So now if you see, it seems better. So now the confusion matrix at least seems better, more refined. Thanks Aditi to tell me about that append thing. So yeah, so this is how it looks like, and now I can say that yeah, it's better because पहले सब mix हो गया था, and so you have to be aware कि भाई मेरा output किस तरह से आ रहा है, सही आ रहा है कि नहीं. अभी अगर हम errors देखेंगे तो comparatively सिर्फ 6 और 4 सिर्फ इतना error है. पहले उसने बहुत ज़्यादा errors दिया था मॉडल में. So I'll put this file, guys, but these some programmatic things where yeah, Aditi and Karan helped me, so I want others also to be aware about these. Yeah, I think yeah, Nishtha also informed. Yeah, thanks Nishtha. Yeah, so these are small things. Definitely you don't need to remember them always. It's hit and trial, but yeah, you should know what to use when. Just clear your programming concepts. Okay, so this was about the light GBM. I'll take 5 more minutes, guys. So the last one is the cat boost. Cat boost, there is nothing much to talk about. The only important thing with cat boost to do is A, you don't need to do much of the parameter tuning. It handles it automatically. That's one thing. But the biggest thing is this, the categorical features. So normally if you have values, right, gender is male, female, you normally cast it into the 0, 1s and all. You don't need to do that. तो SQL में ये सबसे बड़ी प्रॉब्लम थी जो अभी तक सॉल्व नहीं हुई थी, right? So cat boost did that. Okay, so the cat boost is handling categorical features like R handles. Also it has support for GPU like light GBM, right? But light GBM के दोनों वर्जन आते हैं. ये by default आपको सपोर्ट कर रहा है GPU भी. इसकी एक्यूरेसी भी अच्छी है और स्पीड भी अच्छी है. Though it's also working like the other models, the light GBM and the XGBoost internally, but there are some mathematical differences which you definitely should not worry about much. But what happens is cat boost में सबसे important चीजें दो हैं जो याद रखने वाली हैं. एक कि cat boost जो है वो एक तो वो फास्टर है, इवन लाइट GBM से भी फास्टर है और एक्यूरेसी भी उससे अच्छी है. दूसरा वो कैटेगोरिकल फीचर्स पे काम करता है, इंटरनली उनको हैंडल कर लेता है. बस आपको मॉडल चलाते समय बताना पड़ता है कि कौन से न्यूमेरिकल फीचर्स हैं और कौन से कैटेगोरिकल हैं. आपको ये बताना पड़ता है ट्रेनिंग करते समय, सो दैट वो उसको अलग से हैंडल कर ले, उसको बताना पड़ता है. लेकिन तीसरी चीज, चौथी जो भी है सबसे इंपॉर्टेंट, वो ये है कि जो ट्री बनते हैं यहाँ पे आखिर वो क्यों बेटर है या फास्टर है, इज इट क्रिएट्स सिमेट्रिक ट्रीज. सो नॉर्मली whether we talk about level based approach or the leaf based approach, the depth first or the breadth first approach, you get imbalanced trees, something like on the left hand side. But इनको हम asymmetric and symmetric trees कह सकते हैं. But this is a symmetric tree. Symmetric tree as in all the leaves are at the same level. All the leaves are at the same level. It's not some leaves are at this level, some are at this, some are at this. So that's the one thing that they created symmetric trees, which they say you can go through this this thing, this YouTube link, okay, which I have attached here. So this is from the people who generated cat boost, okay. So you can go through it, and this is about the performance of it, along with the errors, log loss, all those errors and all. The log loss they are talking about, what loss they are talking about here. So it may not be the time, it may be the log loss or the errors, how the errors are increasing or decreasing. Just check, just have a look at it. So I think these are this may be the log loss or the errors. But similarly, there is another chart which is talking about the speed, performance time. Okay. So this primarily I think is talking about the log loss or the error, how that's getting reduced, how the errors are getting reduced, not the time. Okay. But there is another chart which talks about the time, which is available here, I think. Yeah. So when we say faster predictions, right? So you can go through this video also. This is an open source, okay? Open source gradient boosting library given by the Yandex. These are a group of people who actually, researchers who actually worked on this, Yandex researchers. So the video YouTube link I gave is good, and this YouTube link is also good. And there are some online performance links. This is specifically about how the errors are getting used. Okay. Then the symmetric trees, as they say that symmetric trees are better and faster. So that's one of the approach. Categorical features, something that they handle, like occupation, engineer, designer, manager. If that's a column, it will handle automatically. There are some hyperparameters that definitely you should remember. Here is again same, nothing different. Learning rate and iterations, the depth, the L1, L2 regularization, the bagging temperature, or the amount of data you pass to each bag. Okay. So just these are some of the parameters that you need to look at. So let's see here. If I just see here again, it's same. From cat boost, you have cat boost classifier, cat boost regressor, you have all those, and then you create an object of it, passing the number of iterations, the learning rate, the loss function. It may be a log loss, it can be a cross entropy. All have their own formulae. You simply fit it and you can predict it. Here it's just telling you which loss function to use. So it's AUC ROC curve and the accuracy, 50 iterations to be executed, the random seed, the learning rate, and by default there must be some classifiers, like maybe 10 or 100 classifiers that it will build internally as part of that boosting, which you can look at. Okay, so that's it, nothing much about it. We have covered pretty much everything as part of this. Please practice this. I'll put this over the net sometime now, and that's it. So you have enough time for 2 days, guys. So I'm just telling you certain things to do. First of all, definitely read about boosting properly, like AdaBoost and XGBoost, GBM, all the slide GBM and cat boost. If you are interested, go behind what's the difference between the log function, the log loss, and the cross entropy. What's the formula for log loss and cross entropy? You go through that. What's the formula for L1 and L2 regularization? Note all these things, okay? Formula for L1 and L2 regularization. How L1 and L2 regularizations impact the cost function. हम पहले बात कर चुके हैं, but it's same. There is L1 norm and the L2 norm. So read about the vectors. Vectors is nothing but a special form of matrix. Okay, row vector and column vector, right? So just go through this. Go through vector algebra, matrix algebra. What is the transpose of a matrix? What is the inverse of a matrix? What is matrix multiplication, right? So with this we we are done with the classification. Definitely also go through classification reports or classification metrics in detail. What is the confusion matrix? What is precision recall, TPR, FPR, and all. Go through all those things, and that's it. I think focus on all these things. The another important thing is you should know you did PCA, right? So in PCA, there is something known as eigenvalue and eigenvector. It's eigenvalue, right? So when you implement PCA, guys, what is eigenvalue? What is eigenvector? Okay. What is I'm thinking, okay. What is covariance matrix? This is all part of unsupervised learning, where we talk about the PCA, principal component analysis. So what is eigenvalue, eigenvector, covariance matrix, and what is singular value decomposition? Okay, read about these, because definitely I'm not going to discuss about these things, but I want you to be aware about it because you already did it. So as part of unsupervised learning, principal component analysis, what are principal components, what is eigenvalue, what is eigenvector, what is covariance matrix, what is singular value decomposition, what is factor analysis. Okay, so all these things are part of PCA. So just go through this. Other than PCA, there is ICA, there is RCA. Read about them. Okay, what is principal component analysis, what is independent component analysis, what is this RCA, I think residual component analysis. So read about these things, and that will cover up your unsupervised learning properly. Okay, so now revise all the things that you have done, whether supervised, unsupervised. Monday is the next class where we will start with time series in detail. So read about time series a bit. We will start time series Monday. Okay. I'm not going to teach about unsupervised learning. You guys have already done it, right? Yeah. So that's what. So I'm not going to teach about unsupervised learning. So just read about it. It's very simple. K-means clustering and all are very simple. Okay. But is there anything which is not at all touched in unsupervised learning, guys? Please tell me right now. Anything which was part of your syllabus but not touched in unsupervised learning? No, Anam, feature selection and all is different. I'm talking about this thing. So Pragisha, is this part of your syllabus? Because I don't know. DB scan and hierarchical clustering, this density based scanning and all these things, are this part of your syllabus? Because otherwise there is too much things in the world. Okay, so I'll check your syllabus. If DB scan and hierarchical clustering are part of your syllabus, I'll touch that on Monday, and then I'll start time series. Otherwise, I'll directly start time series. No problem, Pragisha. I'll check your syllabus. If it's part of it, I'll do that first on Monday, and then we'll start time series. Else, I'll skip it if it's not there in syllabus. Okay. Okay. Thanks, guys. Thanks a lot. Please revise everything that you have done so far. Otherwise, it will become a pile up of too many things. So practice it. Thank you.